Good morning, everyone. We're here to discuss physics and to set straight some problems that I've found and some corrections. I'm not just bringing problems that I've noticed, I'm telling you what the corrections are and what those corrections mean for everyone and how it fixes physics, really, in the long term. Now, I wrote a book, Rationus Physicae, which is what you see here. This video is not about promoting the book. I'm using the book as a model so that I can explain things to you. The book is for sale on Amazon, but it's also for free on the Amazon reader. And I did that because it's about sharing the knowledge. It's not about making money off of the book. The reason I wrote the book in the first place is I flew to MIT over a decade ago to tell them what it is I had found. And the physicist who would actually speak to me said, if I listen to you and get a Nobel Prize, that you can try and steal my Nobel Prize, so I'm not going to listen to you. And I'm pretty sure that's just what they tell people, so that they don't have to listen to them. Kind of a just way to get rid of people. And I'm okay with that. But he did give me some advice. He said, if you're going to do this, go home, write it down, think about exactly what you want to say, get it on paper, and, then you can get it peer reviewed and whatever. Of course, I brought it home, set it down, didn't put it on paper for a while. I finally have. This is the book. But these videos are going to be a series that explain what's changed, why it's changed, how it affects you and everyone else in the world, quite literally. The problem is to get to the points that are juicy that people want to hear, you have to go through a lot of explaining what space is, how you're defining space, how fields are formed, and we are going to do that today. But if we start with that, I have a horrible feeling that many of you are just going to shut this off and move on to another video. So I'm going to practice a little bit of shock and awe communication, and I'm going to do that by simply telling you some of the highlights that I'm going to prove to you so that you know what's coming and you can decide to leave or you can decide to stay and hear what is going to be presented. Number one, if you go back and listen to the great masters of physics, and most of them are correct. There are a few single instances where they made a mistake, and it has changed and held back physics in every way for a long, long time now. The first, magnetic monopoles. They exist. They're real. They're right in front of you. You defined them improperly, so you can't see them. And I'm going to define them properly for you here now. The big shock that comes with that is that not only do magnetic monopoles exist, but they exist directly in your eyesight. You can look up, and it's interesting, that movie Don't Look Up just came out. So, but you can look up and see one half of the day or night, and that's because our moon is a magnetic monopole. So let's start with that and move on to some of the other very interesting changes to physics. How is our moon a magnetic monopole? Well, let's start with Gauss, who created the divergence times B, the magnetic field, equals 0. The reason he did this is because, quite literally, the big argument against magnetic monopoles right now is simply that magnetic field lines can't have a beginning or an end, which is fine. If you think of a charge monopole as a star, and the light leaving the star as its field lines, then the field lines themselves start at the surface of the star and expand outward, and they keep expanding forever. And the problem with that is that magnetic field lines, as defined by Gauss, have no beginning or end. So if you try to build a magnetic monopole in the same way as you built a charge monopole, which is the star, then you can't. So this is one of the clear reasons why Gauss said you cannot have a magnetic monopole. Here's the thing though. If you look at a charge monopole, it is a force in, charge out system. And what that means is that this incredible gravitational field that it puts out brings a force against anything within it and pushes it inward in the system. And then the charge goes directly away. And if we try to build our magnetic monopole exactly opposite to that, then in Gauss's mind, what that meant is you had a core, and it was the very opposite. Magnetic field lines were going both ways out, away from the star, with no end. And of course, that can't happen. But what if instead we define magnetic monopoles as a reversal of the charge and force system, meaning that it's a charge in, force out system, not that the magnetic field lines begin with no end and radiate outward, but that charge starts outward and goes toward the core. And if that's the case, then the magnetic field lines around the force out system would simply be spherical. You would have round field lines with no beginning or end circling the core, which would be absorbing the energy because it's a charge in, force out system. And then we run into another problem. If you have a charge in, force out system, then you have a system that opposes entropy. In other words, the core of the system would be considered a lower entropy than the surroundings. And the second law of thermodynamics says that that's not going to happen. Here's the problem. We know it happens. It happens all over the place. But we have told ourselves that it can't happen unless it's being mechanically forced. And to give you an idea of what I'm talking about here, we would have to look directly into your air conditioning system or your heat pump, where a gas is compressed, pushing the heat outward. So charge is going outward, force is going inward. The force going in is what's compressing the gas. The charge then moves outward in the system. And there you have a force in, charge out system. When you then expand the gas, then the gas is moving outward, which means the force is out, and it pulls the charge inward. So to say that the second law of thermodynamics can't be reversed is a misnomer. It cannot be reversed except mechanically, and mechanically it can be reversed. Your air conditioner is proof of that. So when I say that the second law of thermodynamics reverses, don't start yelling at your computer screen, and don't just turn off the video as someone who can't, know what he's talking about. Obviously, I must be an idiot if I'm saying the second law of thermodynamics, is wrong. But instead, just assume that when I say the second law of thermodynamics reverses, that it's reversing in a mechanical way. Well, the thing is, the universe is a machine, and the galaxy is a machine, and our solar system is a machine, and our planet is a machine. And all of these things are technically mechanical in nature. That's the whole idea of particle physics, is that each of these particles is a part in a system. And if you understand the system, then the rest makes sense. So I am going to use the word syntropy, which is the opposite of entropy, to define moments when, yes, even mechanically, the second law of thermodynamics reverses. Now, under that model, in a mechanical system where the force out, charge in system that we're defining creates a magnetic monopole, and the field lines, the magnetic field lines, circle in all directions around the core of the magnetic monopole, then the magnetic monopole has a syntropic reversal of the second law of thermodynamics, which means charge flows to the core, force flows outward, and the field lines then go around the model. Now, you can define this as isothermal and a diabatic heat transfer and da-da-da-da-da. I want to slap them people who come up with this stuff. So instead of becoming frustrated and trying to explain that the second law of thermodynamics can be reversed mechanically, and each time that we come upon it throughout this conversation, I'm simply going to use the word syntropic to make it easy. So don't yell at my computer, or don't yell at your computer screen trying to yell at me. We know it can happen mechanically. It happens in your air conditioner. It happens in space too. So if magnetic monopoles exist, and they do, and if it can be defined as force out, charge in, and the force out creating circular field lines around a core with charge going in, force going out in a syntropic nature, then magnetic monopoles can and do exist. There. Now, why do I think our moon is a magnetic monopole? Well, there's an enormous amount of data that proves it, and I'm going to hit the highlights here right now. There are plasma discharge marks on the moon. They look very close to craters created by asteroids and comets that hit the moon. But there are others that have not only the crater, but they have lines radiating from them. And they look exactly like plasma discharge marks created in the laboratory. And a scientist, and I can't remember his name and I feel bad about that, but a scientist came out with a paper and said, hey, these are plasma discharge marks. They're on the moon. We need to pay attention to this. And of course he was ridiculed. What do you mean? Aliens came and shot the moon with their phasers, so there's plasma discharge marks. And and that's a reasonable joke to make, when somebody says something like that. But the truth is, there are only 4 possible particles or types of particles in the universe. I mean, no matter how small you get or how large you get, there are 4. And I'll show you, it's in the book, and I'll explain it here. There are charge monopoles. There are charge dipoles. There are force, or what you call magnetic monopoles. And there are force, or magnetic dipoles. And that's it. Those are the 4. So if we start to name each of the particles in our system, and let's start with the solar system, then let's start with charge dipoles. You know what? Let's start with charge monopole. Everyone can know, and I think we'll agree, that the star is a charge monopole. And if you know that that's a charge monopole, and I'm telling you that the moons of the inner solar system are magnetic monopoles, then we have a charge monopole, we know what it looks like. And we have magnetic monopoles, and we know what they look like. And that only leaves our dipole structures. So there's charge dipole, and there's magnetic or force dipoles. And if you look at the inner planets, And for now, let's just look at Venus, Earth, and Mars. And if you look at those, you quickly come to realize that though they appear to be magnetic dipoles, they aren't. And how would we know that? I mean, what proof of there is that? And the answer is Venus has no magnetic field. It looks like Earth. We call it our twin planet, our sister planet. And it has a much larger charge, but it has no magnetic field. So we can't be, these three inner planets that we're looking at, Venus, Earth, and Mars, can't be magnetic dipoles, even if they have magnetic fields like Earth and a small one like Mars. Because Venus, no doubt, is a charged dipole. And the thing is when I realized that, and I realized that the moon was a magnetic monopole, I realized that all Venus, Earth, and Mars are all charged dipoles. So where would the phaser blasts come from that hit the moon? And the answer is, if our planet is a charged dipole and the moon is a magnetic monopole, that a plasma discharge from the atmosphere of Earth would hit the moon and create the craters, the plasma discharge marked craters that were not created by asteroids and comets hitting the surface of the moon. So there you have an idea of what I'm talking about. Now, this creates more problems, if I'm right and the moon is a magnetic monopole, and it is, then we have an even bigger problem. You see, magnetic monopoles inside the charge monopole atmosphere of the sun, meaning our inner solar system, is a positively charged environment. And if the moon is a magnetic monopole, and it is, then what you end up with is the not only probability that the plasma discharge marks are from the charged dipole discharging to the magnetic monopole, but under that model, then the moon is a negatively charged object traveling through a positively charged field of the sun. And then you have to stop and think about that for a second, because that suddenly makes sense. Not only would the planet discharge to it, but you would immediately be able to apply Ampere's law. Now, Ampere's law is another one of Maxwell's equations. The two Gauss created, which are the charge monopole, and they do exist, and the magnetic monopole, and he says they don't exist. But then you also have Ampere's law. And Ampere's law being one of, Maxwell's equations that written by Ampere and the other one written by Faraday. And there was actually only a connection, and it's an orthogonal 90-degree connection made by Maxwell between Ampere's law and Faraday's equation. And this connection is why they're called Maxwell's equations, and it's an orthogonal connection between the two. But Ampere's law is simply a way of defining charges and magnets in motion through the opposing fields. So what I want you to do, and this is experimental, here's your experiment to prove that I'm wrong, which when you do it, you're going to prove that I'm right. So I'm hoping you'll do the experiment simply to prove me wrong, is to apply Ampere's equation, Ampere's law, to our moon. It's that simple. If what I'm saying is true, then our moon is a negatively charged particle traveling through a positive field, and that would create a magnetic field. How? Well, look at Ampere's law. If you consider that a charge in motion is considered a current defined by I in Ampere's equation, then our moon is that charge. Now, the idea, and let me explain it to you, is that if in Ampere's law, if a charge is traveling in a solenoid, right, which is a helical path, so if you have a wire in a helical shape and you send a charge down it, then it becomes a current, and a current traveling in a helical path or a solenoid creates a magnetic field. That's exactly what a solenoid really is. And so what I want you to do is apply Ampere's law to the moon. And the moon is the current defined by I. It's traveling, the Earth and the moon co-orbit each other around the star. So what does that mean? I mean, really, what does that create? Well, it creates a solenoid. Plain and simple. If you were to just take Earth out of the picture and trace the path of the moon, it would be moving forward and in a circular path through space. So there's no wire, but there doesn't need to be. The wire is just to hold the current. And in space, that's not required. So technically, Earth is the wire, I guess, because it's what's holding the moon. But if you apply Ampere's law to the moon, you're going to find that it creates a magnetic field somewhere between the moon and the Earth. And there has been a huge amount of theory done on the Earth having a metal core, iron core that's spinning, and a spinning iron core would create a magnetic field. And everyone says that's where the Earth's magnetic field comes from, and they're wrong, plain and simple. If you apply Ampere's law to the moon, you're going to find that it creates a magnetic field because it's a solenoid, and that magnetic field is not centered on Earth anymore. There was a time long ago when the moon is moving half an inch away a year, and there were a time millions and millions or hundreds of millions of years ago when the moon was much, much closer, that a plasma discharge could occur between the charged dipole of Earth and the magnetic monopole of the moon. But more importantly, just as importantly, that magnetic field would have been inside Earth. And it's been pulled out through our atmosphere until it's now in space. So the core of the magnetic field created by the moon in this solenoid is actually in space. And this tells us why there are places in space where your satellites just go dead. Because this has created a magnetic field. Now, here's the problem, and you're all going to freak out about it. If this is true, then the moon has no gravity because it's a negatively charged particle. And you say that can't be true. We've landed on the moon. We've measured the gravity of the moon, and the gravity of the moon is 1.67 meters per second. And that's a problem, though, isn't it? The gravity of Earth is 9.8 meters per second. And technically, we're supposedly made of the same thing the moon's made of. The moon is a third our size, which means it should have a gravity somewhere at 3 something. But it doesn't. It's only 1.67. And this can be easily defined by me because it's not gravity. It's static charge holding you to the surface of the moon. And I know this is gonna, I must be crazy. That can't be right. So why do I believe that then? Well, A, because the moon would have to be negatively charged for it to create our magnetic field to follow Ampere's law to create the solenoid, which creates the magnetic field of Earth. Then it wouldn't have gravity. Then it would only have static charge. So what other things could help us decide whether what I'm saying is even legitimate and a reason to even do the experiment to apply Ampere's law? Well, when we landed on the moon, the regolith, the surface of the moon, jumped off the surface and landed on all over the suits of our astronaut. And this happened because we are, and our equipment, and the things that we have from Earth that we took there are positively charged, and the moon is negatively charged. Now, I know NASA came up with this thing where the solar winds traveling over the surface of the moon at this particular angle on this particular time causes a negative surface charge, da-da-da-da-da. No. The moon is a negatively charged object. That's why your electronics didn't work or begin to fail and not work when you landed on the moon. It's why the regolith jumps off the surface of the moon and sticks to the spaceship and our suits. And I mean, our suits started to break down within hours, because the negatively charged part just infiltrated the suits. And this is why the moon is negatively charged. So how am I so sure? Well, because Bohr told us. See, in Bohr's model of the universe, there was quite literally what he called pair production, where a positive particle and a negative particle separate. And this pair production begins at 1.64, and our moon is at 1.67, which is to say not only is our moon a magnetic monopole as it orbits us, not only is it negatively charged and we're positively charged, plasma discharge is discharged from us to the moon, but Bohr called this pair production to begin at 1.64, and the moon is at 1.67. So the moon, being a third the size of Earth, should have a much higher gravitational force. And the reason it doesn't is because it's not gravity that's holding you there. It's quite literally static charge. So how can I prove this to you other than just giving you that? Well, let's look at the rest of the solar system and see how things play out. Well, if you look at the other planets on the inner solar system, you got Venus, which has a very thick atmosphere, and it has relatively equivalent to Earth gravitational field. No magnetic field, though. And it has no moon. So if I'm saying that moons of the inner solar system are negatively charged, and using Ampere's law, they create a solenoid, which then creates the magnetic field, then Venus obviously wouldn't have a magnetic field. And Mars has one, because it has two very, 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 very small moons. But those moons are creating, just like our moon, a very thin, very small magnetic field. So, it fits so far. Problem is, when you look at our moon and you look at the other bodies in the inner solar system, you have to immediately notice that while Venus, Earth, and Mars look the same, Mercury does not. In fact, Mercury looks exactly like our moon, just larger. And that doesn't make a lot of sense. If what I'm saying is true about our moon, then it also must be true about Mercury. And that's another big shocker. I know, you know, Mercury is not a planet. Mercury is a magnetic monopole moon. Well, what would that mean? Well, if you look at the surface of Mercury, you find that it has the same plasma discharge marks and the same impact craters from asteroids and comets. And that would mean, quite literally, that at one point it must have circled a charged dipole to get the plasma discharge marks. And since Venus has no moon, you immediately must come to the conclusion that Mercury is Venus's moon, that it already reached pair production and separated, and that the sun's field pulled it in. In other words, Venus lost its moon to the star. And this is not just anecdotal evidence. The whole reason that Einstein came up with special relativity and general relativity was to originally simply define why Mercury's motion in our solar system could not be defined by Newton's laws. So we know, Einstein knew, everyone's known that Mercury itself doesn't follow Newton's laws. Well, Newton's laws are about charged dipoles and positively charged particles in the solar system. Since that's the case, and it is, then we can assume something. If Venus lost its moon, and it did, to the sun, and Mercury was Venus's moon, and it's now circling and orbiting the sun much closer, and it's going faster and faster, then we can say for sure that negatively charged particles travel toward the sun or inward in the solar system over time. And as they do, they get faster and faster. Mercury is speeding up and going faster and faster, but it's getting closer to the sun. That shouldn't happen. If Venus or Earth or Mars were to gain, to accelerate, they would move away from the sun. Just like Earth has an escape velocity, and you must accelerate to that escape velocity to leave. The faster you go, the farther from the planet you get, because it's a gravitational field. And the sun's the same way. The faster you go, the farther you should get from the sun. And Mercury is actually moving toward the sun and increasing in speed. And this doesn't make sense, not by Newtonian mechanics. So we've known that Mercury does not fit into the same classification as these other planets. Because if it did, we wouldn't have special relativity and general relativity. So what does that mean, really? Well, if our moon is creating a magnetic field around Earth, then we must assume that Mercury is doing the same thing to the star. And this creates another answer that we haven't been able to quantify yet. Not only the motion of Mercury around the sun, but why, even though the star, our sun, is a million times the size of Earth, its magnetic field is nowhere near a million times the size of Earth. If it was an internal magnetic field created by the size and the flow of particles, the sun's magnetic field should just dwarf Earth by like 1,000,000 to 1. And it doesn't. It's only a few times larger. So, if Mercury, and it is a magnetic monopole, and it is creating a solenoid around the star, then that is what's creating the sun's magnetic field as well. And this says a few things about our system. It means if we move our moon in or out from planet Earth, then we can adjust the magnetic field of Earth. And I know that sounds strange, except in Bohr's model, and Bohr's model holds here, the moon is a massless object, which means Mercury is technically a massless object. And if you create a situation where you move Mercury in or out from the star, you're going to change the force of the magnetic field. Since it's a solenoid, following Ampere's law, right, the core of the magnetic field of Mercury is well away from the star right now. But the closer it gets, the closer that's going to become. And pretty soon the charged monopole of the star is going to discharge and evaporate Mercury, basically. And this is going to happen in the same way that the plasma discharge marks on Mercury and our moon already have existed. It's going to Since there are plasma discharge marks, then positive is discharging to negative. Now, Mercury's charge is 3 point something, I believe, or right around 3 meters per second, which means it's almost twice that of our moon. The thing is when Mercury gets closer, it's going to start pulling the magnetic fields that surround the sun out, and there's going to be more and more and more solar events. So the sun is getting stronger, and there are more and more magnetic events happening on the surface of the sun. Solar flares, for instance. They're going to keep increasing, and they're going to keep increasing in strength, and they're going to keep increasing in frequency. So technically, Mercury is a lever that allows us to control the magnetic field of the sun. And our moon is a lever that allows us to control the magnetic field of Earth. Now, some of you intelligent people out there are already shaking your heads, screaming at your screen, no doubt, saying this guy's a freaking idiot. He has to be. How would you know that right off? Well, the tides of Earth, let's be honest. The tides of Earth are caused, supposedly, by the gravitational pull of the moon. So, what kind of moron would stand up and say that the moon has no gravitational field? Obviously, he's wrong. Shut off the video. Go away. Problem with that is that science has not fully identified polarity and the structure of molecules and atoms. See, they are also charged monopoles, charged dipoles, magnetic monopoles, and magnetic dipoles. And in the case of water, salt water, they are charged dipoles, just like our planet. Which means it's not gravity that's causing the water to well up in the center and to bulge out away from our planet. It's charge. Charged dipoles are attracted to the magnetic field of the moon. So when they say the moon causes the bulge of the water, the tides, they actually even tell you that if you map it out, the tides aren't trying to reach the moon. They're trying to reach a point between Earth and moon somewhere. And that's never been fully defined or explained, not properly. And the truth is, it's because it's not gravity. It's charge. The charge dipole of water is what is trying to align itself to the magnetic field created by the magnetic monopoles circling us, creating a solenoid whose center is much closer to the Earth than the moon is. And the water, the charged dipole particles, are trying to get to that point, not to the moon. They're not being pulled to the moon, they're being pulled to the center of the magnetic field created by the solenoid that is the moon co-orbiting the star with our planet. And this explains why your satellites go dead in certain spots of space. Because when you enter the core of the magnetic field created by the solenoid, created by the moon, then they go dead. So we can define so many things that can't be defined in other ways. Simply by calling the moon a magnetic monopole, realizing that Mercury must also be a magnetic monopole. And this answers a few other questions. So if this is true, and it is, then our moon is leaving us and will move inward and hit Venus. It will shatter, reform, and become Venus's moon, while depositing many of the molecules made and held within its structure on the surface of Venus. So why am I mentioning that? Why is that important to us now? Well, if this is happening to us right now, And if we see Venus has lost its moon and it's moved inward, then we have to look at Mars and say, why don't they have a large moon like Venus had in Mercury and like we have with our moon? It seems only logical that over hundreds of millions or billions of years that, Mars should also have one. Well, it did. You've heard the modern theory that a rogue planet called Theia hit us, and that's why we started spinning and how we got our moon to be created. And, well, if you take that story and you align it with the model that I'm giving you here, then Theia wasn't a planet either. Theia was a moon. In fact, Theia was Mars's moon. And it hit us, giving us all this water that we have on our surface, which sustained our charged dipole at a very mild level and protected us by creating our moon or enlarging it. And this creates a system now that we can watch. Mars had a moon. It lost it after pair production. It hit Earth, gave us our water. Parts of it reformed, causing our moon to enlarge. Our moon, over time, is now leaving us. And the moon that's leaving us will hit Venus. Venus had a moon. It reached pair production. It is now circling the star. Which means when you accelerate magnetic monopoles in the inner solar system, they don't move outward like charged dipoles in a magnetic or a gravitational field. They move inward. And this is opposite of what Newtonian mechanics say should happen, which is why probably no one's come up with this theory before. But now that I have, you should be able to see quite clearly that magnetic monopoles exist, that they move inward in the solar system instead of outward as they accelerate, opposite of charged dipoles. And that all of the things that we understand, excuse me, like Theia hitting Earth, Bohr's pair production occurring at 1.64, our moon's at 1.67, Mercury being at 3 something, says that we have a new model of what's occurring in our inner solar system. So let's put that on a shelf for just a second and move outward now and look at the outer solar system. And I don't think it's very difficult for anyone to look at the outer planets, compare them to the inner planets, and say they're not the same. Something is off. Something is not occurring. And the reason this is because, well, let's start with the moons of the outer solar system. The moons of the outer solar system are very similar to the planets of the inner solar system. So let's just go out on a limb and suggest that moons in the outer solar system are also charged dipoles, like the inner planets. And some of those moons have small moons themselves. So, just like inner moons, or inner planets, Venus, Earth, Mars, can create moons around them, outer moons, being charged dipoles, can also have moons. That's first. Charged dipoles have an inherent ability to create moons, and outer moons are the same as inner planets, which are charged dipoles. So we've identified the star as a charged monopole, the inner planets as charged dipoles, the inner moons as magnetic monopoles. The only thing that we haven't officially defined is magnetic or force dipoles. And of course, this is where the outer planets come in. Jupiter, Saturn, Uranus, and Neptune are magnetic or force dipoles. Now, what does that mean? Well, it means the exact same thing as the moons, only it gives them a duality charge on the magnetic force, on the magnetic monopole. So what that means is the outer planets, Jupiter, Saturn, Uranus, and Neptune, are magnetic dipoles. Now here's the problem. In the magnetic dipole structure, the final model is an anapole, which means Jupiter is an anapole structure. And in this anapole structure, they are a force-out, charge-in system, just like the inner magnetic monopole moons. So what would that mean? And here's another groundbreaking theory, and that is that the environment that is the atmosphere of these outer planets are a force-out, charge-in system. So what would that mean? I'm saying they are the opposite charge and force system as Earth, or of a charge dipole, which are force in, we call it gravity, and charge out. Well, it means the atmosphere of the gas giants or ice giants is a anti-gravity atmosphere. I mean, think about it just for a second. And we just saw this happen, Shoemaker Levy or something hit one of the planets, and this has happened over and over again. We think of these outer planets as clearing a lot of the asteroids and stuff. And we've seen it occur. And in time, what would that mean to an anti-gravity atmosphere? A charge-in, force-out system. Well, it means that eventually all of these asteroids and comets that hit it would shrink, go to the core, and then be pushed back outward. And as they're pushed outward, they would be pushed into giant structures. So why does Jupiter have 95 moons? Well, because it's an anapole structure with a force-out, charge-in system that we refer to as a charge or a magnetic dipole. And that means that the reason it has 95 moons is because the anapole structure, and I'm going to flip through the book here real quick to show you what an anapole structure should look like. And here we have an anapole, and you can see that inside this anapole are these little circular thing with its own rotation and charge. Inside the electric dipole, this would be our sun. Toroidal dipole, this would be the galaxy. Anapole, this would be Jupiter. And honestly, our universe is an anapole structure. I know that now because I've gotten to the end of all of this that I'm telling you about. And so, while this is what our toroidal dipole, this is what our galaxy looks like, this technically is what our universe looks like. And here's the thing. These little circles and the little circular thing inside is what is creating the moons of Jupiter. And like any charged dipole in a gravitational field, the faster they go, the bigger they get, the farther out they move. And so, Jupiter is an anapole structure with a force-out, charge-in system that is birthing moons. It accepts asteroids and comets that hit it from all over, And they build up in this structure here, right? And that structure, as it builds, gains its own velocity, its own momentum, and it carries it outside the atmosphere, and Jupiter births moons. Now, how do I know? Well, when you get to the end of all this, it's quite clear that the Q4 particles, and I'll explain what Q4 is. If you take the helix around something from the core outward, if this is the core and you follow a helix around and outward from this core, then what you get is quadrants. And the first quadrant is charged dipole, then you get charged monopole, then you get magnetic monopole, and then it comes back around to magnetic dipole. And this is a helix, which means once it continues past magnetic dipole, it becomes charged dipole again. Now, how would that work? And how do I know what I'm telling you to be absolutely true? And the answer is because this is an Anapole structure that creates the moons and then births them. And a charged dipole is simply an inverted Anapole. And the way that works is very simple. The inverted Anapole structure then reverses the force. It goes from force out, charge in, to force in, charge out, and this moon-making interior structure gets flipped to the outside. So why do the inner planets have moons? Well, it's this same structure that's been inverted and is now outside the particle. So charge dipoles are inverted Anapole structures. So what would that mean then to all of physics, really, right off the bat? And the answer is the reason moons form around charged dipoles, like the inner planets or the outer moons, is because they are an inverted Anapole structure. And it's that you're looking at there. Moons form inside the Anapole and are then pushed outward in Jupiter, in Anapoles. But once they invert, then it creates a hole where a moon can exist and starts to form. So how do I know this is true? How do I apply this to other things? And the answer is very clear. Look at a metal hydride battery. It's just a metal structure, which is a bunch of tiny spheres, right, pushed together into like a crystalline lattice structure. Now, why does that store energy? Well, because when you apply an electric field to it, the charged dipole forms around it. So if you listen to science and what they're saying about metal hydride batteries, they're saying when you take a hydrogen atom and you shove it into this metal lattice, these spheres in this metal lattice structure, that they split in half so that they can fit between the atoms. And I can see why that someone would say that. The problem is they're looking at it incorrectly. It doesn't split in half. It becomes the charged dipole, which is half on top and half underneath. So the hydrogen atom actually covers and splits and becomes the charged dipole around each of the spheres of metal. And when it does that, it becomes an inverted Anapole structure. And that inverted Anapole structure creates an electron hole. So our moons are electrons. And when you shove a hydrogen atom between metal, it inverts and becomes an inverted Anapole structure with a hydrogen or with an electron hole. And when you store energy in a metal hydride battery, you're storing it in the electron holes created by the inverted Anapole structure. You should be able to see this in your mind. If you invert this Anapole, then this moon creating spherical interior structure here flips to the outside, and that's where the energy is stored. And if you can see that in your head, then you need to apply it to everything else you know in chemistry. So what I'm telling you isn't just going to change astrophysics, it's going to change chemistry itself. H2O. Well, hydrogen splits to become a dipole charge around an oxygen atom. So when I say that the oceans are rising up toward the magnetic field created by the moon because they're charged dipoles, that's what I'm referring to. So ask a scientist, how does salt water hold the mineral salts in its structure? Well, it holds them as an inverted charged dipole. It's as a moon. As our planet holds moons, as a metal hydride battery holds charge. It's the same exact inverted Anapole structure in charged dipoles that holds the salt, mineral salts and salt water, that holds the electron holes that then, holds the electrons around in the metal hydride battery. And it's the inner solar system moons around the charged dipole planets. And this is why outer planets, moons, can have moons themselves. So charged dipole moons around Jupiter will have electron holes that can hold moons. So now when you go back and look at our solar system, you will see, for instance, the outer planet that's been degraded, Pluto, has several small moons, just like Mars, which means it's a charged dipole. And it's an inverted Anapole that allows it to hold these moons in its orbits, in their orbits. And so the inverted Anapole structure is a charged dipole, which means Pluto is a charged dipole. Since we know that outer moons are charged dipoles, then Pluto specifically is not a protoplanet. It's a moon, and it has its own moon because it's a charged dipole moon of the outer solar system, which has these electron holes created by the charged dipole, the inverted Anapole structure, that allows moons to form. Since outer planets are charged dipoles and inner planets are charged dipoles, then inner planets can have moons, but those moons can't have moons because they have no inverted dipole charge, so they can't create moons. But moons created by charge or force or magnetic dipoles like Jupiter, Saturn, Uranus, and Neptune will be charged dipoles. And those charged dipoles then have an electron hole around them created by the inverted Anapole structure. And those can have moons, which means Pluto is a moon. And very large moon of the outer planets. And it has its own moons. So there is no structure in our solar system that really quite works the way you thought that it did. The outer planets are Anapole structures, charged dipoles, or magnetic dipoles, and they are birthing interior structure. This and that is moving out, and those are moons. So we now have a clear model of our solar system that is completely different than what we had, than what you thought it was at the beginning of this video. So how far can we take this? In other words, if magnetic monopoles exist, and they do, how can we and why would we continue to extrapolate? And how far can we go? What else can it explain? Well, I want you to consider something. We've been talking about Maxwell's equations, Ampere's law, Faraday's law, and Gauss's two equations. And those are the four equations that make up Maxwell's equations. So can you imagine that all electronics on Earth stem from those four equations? In fact, all of our communications stem from those four equations. And most of what we understand, including photoelectric effect and many other things, are due to those four equations. So imagine what would happen if one of those equations was wrong. If somebody said magnetic monopoles can't exist, and they did, well then 25% of all of the knowledge that all of our modern technology is based on would be wrong. Imagine solving that in your own mind. Seriously. What changes would come to Earth, to communication, to technology, if we found that 25%, a full quarter of all of the hardcore equations and knowledge that we had was just wrong and that we didn't understand it? It would change everything. Everything. It would change the way we looked at our solar system, communications, technology in every field. Chemistry itself would change and is about to, because magnetic monopoles do exist, and because Gauss's second equation is about magnetic monopoles, and, well, he was wrong. The divergence of the magnetic field does not equal 0. It equals 1. It exists. It's a thing. And when you look up at the moon, you see one. And when you grasp that and what it's doing, then you have to apply it to Mercury as well. And that defines what's happening to the star. And this is where we have another analytical moment that changes everything. See, if Mercury's Venus's moon, and it moved inward as it increased in velocity against Newton's laws, then Newton's laws don't apply to magnetic monopoles in the inner solar system because they have no gravity. And that should scare the living hell out of you, honestly. Because we believe gravity to be a universal force, and that gravity applies to everything, and it doesn't anymore. If Mercury isn't contained within that, and our moon isn't, then the moons of the outer moons of the outer solar system also doesn't apply to. If energy in the form of magnetic monopoles is diverting inward toward our star, and I'm going to do a quick, I'm going to bring over a little, and I'm going to show that if this is our star, right? Let's see if I can make it a little clearer for you. And that Venus, Earth, Mars, and we've got the Kuiper belt. We've got Jupiter, Saturn, Uranus, and Neptune. We've got Mercury here, and it's moving inward. We've got these three planets, and the faster they go, they're moving outward. Earth, we'll put an E here, a V here, and an M here. It's Venus, Earth, and Mars. And our moon is moving inward. When in pair production completes, then Mars has two very small moons. And if Theia, if my model is correct, and Theia was actually the moon of Mars, and it hit us, then Mars's moons are moving this way, while Venus, Earth, and Mars are all moving outward. So we can see that magnetic monopoles are moving inward into the inner solar system, and charged dipoles are moving outward. So if we come out here and we put 95 plus moons around Jupiter, and these are all moving outward. And we know this because Pluto's out here, and along with some other ones that are out in the asteroid belt out here around, or the past Jupiter, Pluto. Then these moons out here, which are charged dipoles, are also moving outward. Right? Pluto's moving outward. It's got a couple of moons, but those would be moving inward. And that means that these outer planets are magnetic dipoles, which we've already discussed. This is an Anapole structure, Jupiter, that is birthing moons, and they're going outwards and flowing this way. So what we see here is that the smaller moons around Jupiter get larger and larger and larger as they're moving out past Pluto, and we get this charged dipole V. Smaller particles getting larger and larger and larger and larger and larger as they move outward. So if you were to take this and set Venus, Earth, and Mars at the end of it over here, you'd get that same V going outward. Mercury is the largest charged monopole. And then it goes down to our moon, a couple small ones here. And out here we've got these small, like Jupiter's, like Pluto's moons, and some other small moons of moons in here. So this is actually going, right? They're getting bigger going this way. And the thing is if you take these and set this out here, Jupiter, and these are negatively charged, centropic charge, or magnetic dipoles. And so you get this V at the beginning of here, and this V from the planets getting larger sets at the end of this. And so what you get is negatively charged particles moving inward, right? And you get positively charged particles moving outward. So let's stop and consider that for just a second. If this is true, and it is, then what is causing the planets to stay in their respective orbits isn't gravitational. It's what's called orbital resonance. And orbital resonance is maintained by the passing of energy and matter inward and outward. So Venus lost its moon, which will cause it to increase in velocity and move slightly outward. Earth has a big moon, right, that it got from Mars. But when Mars's moon hit us and became our moon, it slowed Earth, which means Earth is technically moving slightly inward as it slows. And these two get closer. And the closer they get, pretty soon our moon leaves us and hits Venus. Venus will then slow and start moving back in slightly, and our Earth will accelerate and move outward. Mars's moons are growing, so it will begin to slow and move inward as Earth moves outward, and when they get close enough, Mars's moon will leave it again and come to Earth. So the passing of charge in the form of magnetic monopoles or moons moving inward and out causes the planets to move in and out in their orbital resonance, maintaining their orbits. That is happening here, and it's happening the opposite out here. Since these are negatively charged particles in the star's positive field, then these small charged dipoles are moving outward. Well, I'm sorry about the art. I'm a horrible artist. I'm a theoretical physicist. I don't do art very well. The problem here is, well, it's not a problem. It's a solution. Think about an ice skater extending their arms. They slow down. They pull them in. They go faster. Same thing's happening to the star. The energy being passed in the form of moons inward is accelerating the star, and the outer moons, being charged dipoles with gravity force, they're being sent outward. So the outward motion of the outer moons maintains the orbital resonance of the outer planets, They'll move in slightly and outward slightly, passing moons, until the moons trail off into space. And this slows the star, obviously. It's just that it's that skater. Put your arms out, you slow. Pull them in, you go faster. So the inner planets are sending moons inward in the form of energy as part of its orbital resonance and increasing the speed of the star. So this is a field created by the star, our solar system, that has a natural ability to accelerate and decelerate the star on its own. Well, what does that mean? Let's be honest. Well, it means that every 11 years, the polarity of our star flips. And what causes that? Well, it's the acceleration of the inner planets fighting the deceleration of the outer planets. And so this acceleration and deceleration has created a very stable, repetitive acceleration and deceleration that causes our star to travel in a slightly helical path. Now, this is why our star isn't just straight. It's slightly going like this. It's accelerating and decelerating a little bit every 11 years. So ask any scientist you've ever heard of, or any scientist watching this, explain to society, to people, why the star flips every 11 years. They still don't know. And I'm telling you, this is what's causing it. The thing is, this is very exciting. The thing is just like our moon has reached pair production, and Bohr was right at 1.64. This ties our solar system and what's happening into quantum mechanics and all the unanswered questions of quantum mechanics. So let's hit that real quick. What would happen if you had a particle in a cloud chamber? And a cloud chamber is a chamber with a magnetic field, right? Dirac came up with this theory, this equation. He didn't even want to publish it. It freaked him out so much. Where the same particle on either side of his equation could be either positively charged or negatively charged. And one day, a scientist was working with cloud chambers. They call these antiparticles. Anything anti you've ever heard of comes from Dirac's equations. And so one day, a scientist, I don't know his name, I'm sorry, was working with a cloud chamber, and particles were all veering left as they were going through, and suddenly one veered right. And he stopped to think about it. He said, oh my God, if it has an opposing charge as it travels through this magnetic field, then it is an antiparticle. And the science of antiparticles exploded. I don't mean to laugh, Here's the problem. Our galaxy is a cloud chamber. Literally, it's a cloud chamber. It's a magnetic field in space. So, positive and negatively charged particles would move in separate directions. The thing is that's what's happening to our star. When it accelerates, it becomes positively charged and moves slightly this way. And when it decelerates, it has a negative charge and it moves slightly this way. And if that's the case, then the difference between positive and negatively charged particles is acceleration. Period. There is no, this particle annihilates that particle. It's all been overblown completely. When you see one particle in a cloud chamber move one direction and another one moving the other direction, even if they have the exact same momentum, what's happening is one has this, equal momentum, but is in the state of deceleration. And the other one has the same and equal momentum at the time, but is in the state of acceleration. And that's the only difference. Now, you can say, no, that's too simplistic. It wouldn't do that. But We live in a decelerating system. We are constantly decelerating to the planet, which is why we're stuck to it. When we accelerate, we move outward in the system. We go to space. That's why we call it escape velocity. We escape the planet when we reach a certain acceleration. And you must accelerate to that point to move outward in the system. So when you have a magnetic field and it's moving inward and outward, one is decelerating, one is accelerating. That's the only difference. So how would that occur in the experiments that they're doing? Well, you have a cloud chamber and all of them are moving to the left and suddenly one moves to the right. Well, what happened is one of these other particles hit that one like a bowling ball, transferred some of its energy and veered left real quick, accelerating this single particle for just a moment during that time that it passes through the cloud chamber, causing it to veer to the other direction. And that's it. That's why you find them. And you say, no, it can't be that simple, Well, why do you think they can't maintain antimatter or antiparticles? Because they must, if what I'm saying is true, and it is, they must constantly be in a state of acceleration. The moment it begins to decelerate, not maintain, momentum isn't charge. So if you're going 1,000 meters a second, right, you're just going to go straight. If you're going 1,000 meters a second and you're decreasing, you're decelerating, you'll curve to the left. But if you're going 1,000 meters a second and you're accelerating to 1,001 or 1,000 more, you'll curve to the right. So momentum hides this acceleration and deceleration flip of a switch that causes things to move left or right. And that should scare you. Why? Well, because science has exploded onto this scene with all these antiparticles, the positron and all of these other things that are, well, it's just the same particle that's accelerating relative to deceleration. That's it. Period. Every single one of them. There is no antiparticles. There's anti-acceleration, which is deceleration. And I can prove it to you. Because our star is doing it. And that's why it flips its polarity every 11 years. So if our star can flip polarity every 11 years because of acceleration and deceleration due to the star, and that causes it to create a slightly helical orbit through space because it pulls one way and then it pulls the other way and then it pulls back this way because it's flipping back and forth in its polarity and its positive and negative charge, then the same thing's happening in your cloud chambers, quite literally. But this is good news. And it's good news because Dirac's equation didn't have a single output. Right? Dirac's equations, it says, had two outputs. But in reality, there were four. So this is negatively charged. This is positively charged. And these two, Dirac just ignored. Why? Because this is almost zero or nothing. And this is the addition of both these two. So since this is different than this, but this side is both of these, and this is neither of these, he just ignored these two. But Dirac's equation actually has four outputs. And since this is charge, positive charge and negative charge, then this becomes polarity. Okay. So this is both positive and negative charge, creating a dipole, and this is neither positive or negative. So this line is polarity, and this line is charge. And this is the real way that Dirac's equation should be interpreted. And how do I know this? How am I so positive about this? Well, I'm going to explain it all to you it's in the book, and I'll explain it here in the video. I'm not trying to, get people to read the book just for the point of reading the book. It's about sharing the knowledge. And the reason that this works is because any unitary system, any single system, will have binary outputs. And any binary system will have quad outputs. And any ternary system will have 8 outputs. It's just the way that things function. So this is a binary system with quad outputs. And these quad outputs occur because this particle is moving down on this page, right? And that creates a density difference ahead of the core, where ahead of this core we have particles in the way being moved outward and charges then being moved inward. So this is a force out, charge in system below this. And above it, up here, right, you have a, behind the particle, the particles that were forced out of the way then move back behind it. So you have a force in, charge out system. So a unitary particle, this core, being downward on the page, right, is creating a binary system of force out, charge in below, and force in, charge out above. And that binary system creates quad outputs, which are charge and polarity. Well, what does that mean? I mean, it's easy to say it, it's easy to point to it, but what exactly does that mean for physics? Well, it means that if our star is accelerating and decelerating because of orbital resonance passing energy inward and mass outwards, and it is, then the only other thing, the antiparticles causing things to move, that's a big thing in quantum physics and physics in general. But the other big thing is quantum tunneling. And I guess I've moved this too soon, but if this is charge flipping when acceleration or deceleration is opposite each other, and these two can flip, it means these two can flip, which means neither existing or both existing is polarity. And neither and both then define, quite literally, quantum tunneling. A particle exists over here, vanishes, and reappears over here through a barrier it shouldn't have been able to go through. And that's not possible because it suggests moving faster than the speed of light. Well, if this is a field created by this core, as I just defined, and we know, because our star is doing it, that charge can flip just like that, then polarity can flip just like that. And a particle that exists would vanish, both would become neither, and neither would become both. So we can take the model of our solar system, which is an experiment you absolutely can do. This isn't M theory or string theory or, multiverse theory where you can't actually test it. I'm telling you, take Ampere's law, apply it to the moon, you'll find that it's created our magnetic field. This will tell you that it's a magnetic monopole. Look at Mercury. You'll see that Mercury is the same thing around the star. You'll see that that means that these magnetic monopoles are being pushed inward against gravity, against Newton's laws of physics, which they shouldn't be. We know this is true because that's why Einstein came up with special relativity and general relativity. And when you notice that the opposite is happening outward in the outer system, that it's losing mass outward to slow the star, and energy is moving inward in the form of moons to accelerate the star, that this fight back and forth flips its charge from positive to negative. We call that flipping of the magnetic field, but it really isn't. It's flipping of the charge. And that means if you can flip charge, then you can flip polarity. And if you can flip polarity, right, if the sun changing charge from positive to negative is reflected in quantum mechanics and in the physics of cloud chambers on the very smallest scale. And it's happening in our solar system, and it's happening in the smallest systems that we see and can test, that the same thing can happen to polarity. And that means that quantum tunneling is just that same flip from acceleration to deceleration, flipping the field of polarity, causing a particle, the toroidal vortex really, on one side of the field to vanish and appear on the other side, which then causes a particle to appear over there. So, since I'm telling you how to very simply test experimentally the negative charge of our moon, and therefore the negative charge of Mercury, and that's going to change the flipping of this, you have an experiment that not only changes your view of our solar system, but should dramatically change your view of quantum mechanics. And the reason that this can function this way, and I understand it, is because any singular system, any unitary system, has a binary output. And any binary system has quad outputs. And any ternary system has 8 outputs. And this is true everywhere, on every scale. I'm going to take a quick break, and then I'll come back and I'll explain why all of this is. All right, we were discussing how Dirac's equation talked about antiparticles, that it's actually talking about quad outputs to a binary system, and that the charge and polarity of Dirac's equations are actually meant as proof that the field can flip based on acceleration and deceleration relative to the core, and that if you can flip charge like you can on our star, that you can also flip polarity like we did on our star, and that this explains quantum tunneling, this explains antiparticles, and this is a direct connection between large physics, quantum mechanics, quantum physics. And we're not going to stop there. But we are going to go back now and begin at the beginning of the book, where I can use the images in the book to prove to you what I'm saying. And in this case, we're going to start. I'm going to skip all the beginnings. And go straight into the model for you. Field theory. I have a problem with the way physics defines fields. Modern physics, especially, let's talk about the Higgs particle that has been supposedly found, and that how the Higgs mechanism is the Higgs field, which permeates all of space equally. First of all, there's no such thing as something that permeates all of space equally, ever. It just doesn't exist. So, a field that exists everywhere that gives particles mass is BS. So how does it work? Well, every field starts from a core and is a localized thing. So you create a core, and that core, moving outward, creates its own field. And every particle with motion creates its own field. The problem is, how are you going to define these things? And how are we going to talk about them? And in this case, first chapter in the book, Field Theory, is about defining space so that we can build our models correctly from a core outwards, not from a field that permeates all of space equally. It's not a thing. Now, most of you have probably heard of Euclidean space. You can see you get the XYZ axes, and if you put space within that, you can create cubic space using the XYZ axis. And to physicists, all of space exists in a way that you can define it this way. Here's the problem. I differentiate dimensions like the X, Y, and Z axes. Each one is its own dimension. But the problem is science doesn't seem to grasp yet, though I'll explain why. All dimensions have a vector, which means they start from a core, and like the rays of the sun, they move outward in a straight line. So 6 dimensions of space here, not just 3. You can see the 3 that we had, right? If you just cut it off here, then these out here are the 3 dimensions of space. So all we've done is put another 3 dimensions. So when you hear string theorists, or M theory especially, talk about, string theory talks about 10 dimensions, M theory talks about 11 dimensions. But they also say you can't possibly know where they all are. They're curled in on each other, or, it's all bullshit. Dimensions are exactly what they seem to be, but they have a vector, which means this upward arrow is a separate dimension from this core than the bottom dimension with an arrow. So up and down is 2 dimensions, left and right, front and back. This represents 6 dimensions. So when string theory or M theory are talking about 10 or 11 dimensions, 6 of them are in this right here. How do I know that? Well, because all fields start from a core and radiate outward. And you can't radiate in both directions at the same time. So they are different dimensional vectors. So this is 6 dimensions. Now, why would that be important? Well, back here with only 3 dimensions, you have 1 cubic space. But there's nothing separating that space. You can know nothing about that space. You only know that there's space. There's no other knowledge you can get from it. If, on the other hand, you have 6 dimensions, then you actually need 8 cubic spaces, right? So this arrow pointing up, this is a dimensional vector. And in order to surround that dimensional vector, you have space to the right of it, space to the left of it, space behind it, space in front of it. And it takes 4 cubic spaces to surround that one. And this is true of all 6, which in order to surround all of the 6 dimensional vectors of space, you need 8 cubic spaces. Okay? And that's what this image is here. It's easy to see, easy to understand. Well, once you have 8 dimensional spaces, right? We call these quadrants of space. So this is quantized space into quadrants based on dimensional vectors from the core outwards. And the thing is you've got 4 on the right and 4 on the left, and in between that you'd have a dimensional plane, right? And you've got 4 on the top and 4 on the bottom. Between those you've got another plane. And you've got 4 in the back and 4 in the front, and between that you've got another transitional plane. So you end up with 3 transitional planes, right? Between your 8 quadrants of space, which surround your 6-dimensional vectors. It's not hard to understand. Take a second, grasp it fully. This is very important. If the core, and remember, all fields radiate from a core. So if the core has a vector down on the page, right, then this flat plane between the upper 4 quadrants of space and the lower is the plane of density. Right? The plane that goes down the middle separates positive and negative charge. So this is the plane of charge. And the front and the back split monopole and dipole. So this is the plane of polarity. So you have a plane of density, a plane of charge, and a plane of polarity. These are the three planes. Now, one thing I'm going to repeat again and again, because it's absolutely true, is that a unitary system has binary outputs. A particle of 1 has a pressure or a density difference below it compared to above it, or whatever direction the vector of the momentum is moving. So this unitary system, this unitary particle, has a binary system that it creates, a front and behind it. And that binary system has quad outputs. Okay? And it happens on the surface. So those quad outputs, right, have 8 possible dimensions of space, or 8 quadrants of space around the 6 internal dimensional vectors. And this is important because one unitary system has a binary output, binary system has quad outputs, and a ternary system, a system of 3, has 8 outputs. So the particle, the core, is our unitary system. Right? And the binary system it creates is the plane of density above and below. Right? And that creates the other 2 charge and polarity transitional planes. So when I say a ternary system has 8 outputs, the ternary system itself are these transitional planes. 1, 2, 3. Those 3 transitional planes have 8 outputs, which create the quadrants of space. That's it. Very, very simple. Now we're about to get to the point where we're going to tie this in with what we were just talking about. And the way we do that is very simple. De Broglie. I love this guy. One of the biggest unsolved or biggest questions in physics that everyone sees and has heard of is the double slit experiment. Well, de Broglie defined it using pilot waves. But people turned away from that interpretation and went another way. That was a mistake. De Broglie's pilot waves are the correct solution to the double slit experiment. The double slit experiment is defined as wave functions that either cancel each other out or amplify each other to create statistical probabilities along the wall. And the way that this works, I'm going to do it real quick, is that through the double slit, you end up with a very light line, and then more, and then even more, and then even more. So this is almost blacked out, this is almost blacked out, this is partially blacked out, and there's only a couple that land over here. And the way that this works is the same way that the orbital field works through Dirac's equation. One or the other, neither and both. Now, the problem I had with Dirac's equation, which was what we were talking about on the last little sheet here, is this. When I first started studying Dirac's equation, I made a horrible mistake. I assumed that positive and negative charge were equal, half and half, basically. And it was only, the breakthrough in this only came when I came to the conclusion that this is 1/3, this is 2/3, both then becomes 3/3, and neither becomes 0/3. So the quad outputs to Dirac's equations are 1/3, 2/3, no thirds, 3/3, or one or the other, neither and both. And this is important because this is the quad outputs to orbital fields, which they're all things that we understand are either linear fields or orbital fields. And Dirac's equation was defining orbital fields, which you call Schrodinger's wave function. So I get that. My orbital field is Schrodinger's wave function and is defined by Dirac's equation. When you define Dirac's equation as polarity and charge, one or the other, neither and both. No thirds, 1/3, 2/3, and 3/3. Okay? With me? Now let's go to the next thing where we talk about de Broglie. Well, de Broglie, when you set the double slit experiment, what you're really doing is turning orbital fields of the photons and the light particles into wave functions on a linear plane. And so what this is 0/3, 1/3, 2/3, and 3/3. And this is why they call it statistical probabilities. No thirds doesn't mean none. It means neither. Neither thirds is not zero. Just because there's a zero statistical probability that the particle will land here doesn't mean it won't land here. Because it's not none, it's neither. And that's very important. Keep that in mind. Then 1/3, remember, charge is not equal half and half. It's 1/3, 2/3. So you have neither third, 1/3, 2/3, and then both combined. So think about how you define wave functions in your mind, in these videos you put out, in the physics books that you read. They either cancel each other out, 0/3, or they combine, 3/3, or they stay their own separates, 1/3 and 2/3. And what you're seeing on the other side of the double slit experiment, on the wall, on the back piece there, is the statistical probabilities laid out in a linear field. So you're taking an orbital field and you're laying it, you're causing it to project on a linear surface. And that linear surface is showing you the statistical probabilities of the orbital field as defined by Dirac's equations, not my equations, of 0/3, neither, 1/3, 2/3, or 3/3, both. And this is statistical probability. Your wave function is defining orbital fields in a linear frame. That's it. That's your, in the end, your double slit experiment. And I know the way I find things sounds too simple to be true, but in the end you're going to find that I'm absolutely correct. So de Broglie's wave function, I know you can't really read this. I tried to make it so you could read it, but I'm really not good with computers. I'm excellent. I can build computers. I just can't use the freaking software the way they use them. So I try not to. But this is a core. You can see the dotted line with the arrow pointing down. It means that this field is moving down on the page. This core, this particle, is moving down on the page. Now you'll see it says alpha h, which is the Planck constant, right? Equals 8 pi squared particles. Now 8 pi squared particles, so that you're clear, we've already talked about them. They're an Anapole structure. So these are, this core, in this case, is made of tiny Anapole structures, like electrons, only very, very, very small on the Planck scale. They're Q4, 8 pi squared Anapole structures, and they're very, very small. In fact, the Planck constant is the charge of one of these Anapole structures. What do I mean by that? Well, the electron, which is also an Anapole structure, has the electron's charge. It's very well known, highly experimentally tested. You know what the charge of the electron is. We also know that it's the charge of the proton, but a positive charge. And you say, well, why is that? Well, we've already defined it. The Q4 particle is an Anapole, which is the electron, and we'll get to where the charge comes from in a second. I'm not going to jump there now, but it is an inverted Anapole that creates the dipole charge of the proton. In other words, a proton is a planet. a dipole charge. And it creates an inverted anapole with an electron hole around that proton, which is what we were talking about with the planets. Inner planets can create moons. Moons are electrons, really, and they're negatively charged particles that are formed within the inverted anapole structure of the charged dipole. Since the proton is a charged dipole, like the inner planets and the outer moons, it can also hold electrons. And those electrons are the moons of the proton. Why is the charge of the proton positive, equal and opposite to that of the electron? Well, because the electron is an anapole structure, and if you invert that around a chemtron particle or a structure, then it gives it the equal and opposite charge of the electron. So when I say the hydrogen atom creates a dipole around the metal structure in a metal hydride battery, or around an oxygen atom to create water, then what I'm saying is the exact same thing happens here around the proton when an electron is inverted to create, right? And that inverted anapole structure is what gives it its mass. So the proton of the mass of the proton is created by the inverted anapole structure of the electron, and it also gives it the electron hole where the moon forms, or the electron begins to form around protons. So we're talking about the exact same thing here. The thing is when you get down to the Planck scale, this is how dark matter becomes baryonic matter, quite literally. So when you have a Planck charge, the smallest charge that there can be, it has to be created by something. It's created by an anapole structure. And that anapole structure is an H equals 8 pi square particle. And when you get to quarks, which then are dipole structures in the inner solar system or the inner nucleus of an atom, they will have charge equal and opposite that of the Planck charge in that quantization. It'll be quantized to the Planck constant. And the same thing is true, like the electron to the proton. So these 8 pi square particles of the smallest that can exist are actually anapoles, which means they're made of much smaller particles in motion to each other, creating that anapole structure. And if that's true, then we have no idea what a fundamental particle is. There are no fundamental particles the way that we look at them and the way that we think of them. They can't be, because the charge comes from the anapole structure. An anapole is made of multiple objects and multiple things. And if the smallest thing we know of is a Planck scale, and the Planck charge is the smallest charge, and we equate that to the electron's charge, then when you invert that charge onto a particle, a chemtron structure, which is what I call dark matter, because, I understand that dark matter was created with a gravitational, to fix the Newton's gravitational model. Why planets and stars and other things are moving in certain ways, in certain directions. And that in order to get more mass, more gravity in certain spots to make them move at the speeds that they do, dark matter was created. And here's the thing. Dark matter has no, atmosphere. An atmosphere is what we call the inverted anapole structure around it, which gives it its gravitational force and therefore its mass. And because this is the case of the electron to the proton, we see it around our own planet, then we know quarks and smaller than quark things build the same way. So this is quantum gravity, absolutely. The inverted anapole creates the gravity in our atmosphere, around Venus, around Earth, around Mars, around the star, any positively charged object that does create a gravitational field around it. That gravitational field is caused by the atmosphere of that particle, which is why Mercury and the moon have no gravity. Why do they have no gravity or no mass? because they have no atmosphere. And it's the inverted Anapole structure that creates the atmosphere that causes gravity, that causes mass to form. So if you're measuring mass in a particle, it's always a dipole. We know that. It has to be, because that's the only ones that have atmosphere. If it was a monopole, it wouldn't have an atmosphere, couldn't have charge. And anyway, back to this. These particles are 8 pi squared, Planck constant, Q4 Anapole structures that are making up this core. Okay? So, probably went a little far in that explanation for this early, but let's move on from there. This core, moving down on the page, moves, and you can see the big black dots and white dots moving outward and swirling around. That's force out. And these dotted lines moving inward is charge in. So we have force out and charge in front of this particle. And behind the particle, it reverses. We have these force in, charge out condition. And this is what causes de Broglie's pilot wave. The thing is because you have equal and opposite forces above this plane, it's a standing wave. It's a standing pilot wave, in a way. So it doesn't vanish. The wave just moves up and down without moving outward or inward. So de Broglie was right, hands down. I'm not trying to take from him. He didn't quite explain it right. He used pilot waves when he should have used standing pilot waves. But he's still right. And he does define the double slit experiment in a way that is mathematical and accurate. And you don't need all the other bullshit of unknowns that come up with the modern interpretation. But I'm getting off track here. We're going to go back to defining fields and structures and how it works. So we've defined a core traveling down on the page across this plane with force out, charge in below that, and force in and charge out above that. And the way that this comes out is basically like the surface of water, right? You have a more density below, less density above, and you have a core traveling down, and it creates pilot waves. But as we just defined, they're standing pilot waves. They're not just pilot waves, they're standing waves. And this is just a simple way of explaining it. I don't know if you can read this very well, but let me see if I can. Kinetic energy above with the particle moving down, potential energy of the system pushing back against it, creating, with the velocity downward, creating quad outputs, right? And those quad outputs can be defined as displacement and charge. So displacement and charge opposite each other, back and forth, as we talked about in de Broglie's wave, creates a surface of kinetic and potential energy that is defined, that surface itself is defined by, the Hamiltonian or the Lagrangian. It's the same thing. That's what they're defining, the kinetic and potential energy that plays out on that quad outputs, polarity and charge, of this flat surface of density, right? So the density difference is created by a unitary particle creating a binary system, and that binary system has quad outputs of displacement and charge opposing each other, and that causes currents around the core. This is the field, and those currents are what we're looking for and how we're going to define fields and how they form and function. So, field theory, we have to define space as quadrants of space. There are 8 quadrants of space because of the 3 transitional planes. Those 3 transitional planes are the ternary system that creates the quadrants of space. And they're created by the binary output causing quad, the binary input causing quad outputs. And the binary input is actually created by a unitary particle creating a density difference ahead of and behind it. So one particle, a unitary system, creates a binary system of density, and the surface of the density between the two densities, right, creates quad outputs of charge and displacement, which we consider to be charge and polarity. And those quad outputs, when defined through ternary system, and that system is the transitional planes of density, charge, and polarity, create 8 outputs. And those are the 8 quadrants of space. And when you understand the 8 quadrants of space in any field around a particle with velocity, then technically you can define anything. Any system is definable through the model that I just showed you. So let's start with how we can visualize this so that we understand what it's actually saying. Quark, as I've already defined, is a dipole. But let's just list some of the smallest things we know, and they get bigger along the way. You'll notice it's not everything. There's a lot of things in between here I'm not listing because this is a book. I'm not going to list every possible particle that's ever existed. But let's start with some of the smallest. The things that make up what they say makes up the nucleus of an atom. Quarks, there's supposedly 3 quarks within the nucleus of an atom. There you notice there are 3 internal planets in the inner solar system. This isn't a coincidence, at least not for now. But quarks, then neutrinos, which still haven't been identified, but you will, hold on. Then photons, and then electrons. And then let's jump up another scale level to proton, right? Neutron, hydrogen, helium. Now we're going to take a skip. We're going to go through a lot of particles, most of the ones that we live on or that are in us, like cells and everything, because I'm not going to get into that right now. It's way too complicated. So let's jump to things bigger than us. These are things that are way smaller than us. Let's jump to things that are way bigger than us. And you may not understand it, but there is a difference between comets and asteroids. Comet can't have moons, right? Because it's not... I've got these backwards. Anyway, not important at this point. But a comet can't have moons, right? Because it's not a charged dipole. Which means it's in the wrong position here. It should be switched with asteroids. Asteroids can have moons because they are charged dipoles. So asteroid and comet should actually be reversed here. It's my bad. I didn't catch this before when I went over the book. But then you have moon and gas giant, right? Followed by planet, star, galaxy, and universe. So we have different levels. That's really going to bother me. But we have different levels of different things, each growing larger and separating. Now let's start by simply, you'll notice that these things come in pairs. Like quark and neutrino are both positively charged, photon and electron are both negatively charged, proton and neutron are both positively charged, hydrogen and helium are both negatively charged, comets and asteroids are both positively charged, moons and gas giants are both negatively charged, right? Planets and stars, and I understand that there are different moons, but this is Dirac's equations, positive and negative inside the field. Around the star we have a positive charge, so moons are negatively charged. In the outer solar system, the atmosphere, the planets are negatively charged, so the moons are positively charged. So this is just to get you an idea of what we're talking about here. But stars and planets, positively charged. Galaxy and universe, negatively charged. Okay? And the thing is if this is the case, once you set them up like this, once you view them as positive and negative every 2 systems, this appears to look strange. If you have charge, and remember the core that we were talking about is Q4 Anapoles, which means they're negatively charged. So if our core was negatively charged, that means charge is moving toward the core. Okay? And that would go up above negatively charged, then down below positive, and it would if you can see, it would kind of go up and down like gears above and below these things. The thing is if this is a negatively charged core, which is what we've said, it's an Anapole structure, made of Anapole structures, then displacement would be moving outward, right? Force out, displacement is force, so force outward, charge inward. We've shown charge going inward, above, and below. This would be the opposite. So displacement would go above and then back down below and then back up. And you'd get this reversing, almost like gears, causing things to go up and out, which give them spin. And if you then apply polarity, which is this model here, right? The quark would be a charged dipole. The neutrino would be charged monopole. Photon would be a magnetic monopole. The electron would be a charged magnetic dipole. And you can see I've given little icons next to each one. So this small little one is the icon for charge dipole. This is the icon for charge monopole. This is the icon for magnetic monopole. And this is the icon for magnetic dipole. And you'll see on the surface, or on the cover, see if I can get it out of the light here, so where you can see it, that this is a solid particle with a field, a dipole field. So this is a charge dipole. Same model here. This is a charge monopole. This is a magnetic dipole, and this is a magnetic monopole. So each one of these has now been given on our list, radiating from our core, its own little icon. So anytime you see one of those icons, you know exactly what I'm talking about. And you can see, which you will over here, that particles and waves exist equal and opposite each other. And again, I've created the icons next to the words so you can see what they are and how they would look. And when you take the amount of space covered by each one, I found that it exactly matches the yin and yang. And that just blows me away. So the yin and yang are actually showing the polarity structure equal and opposite each other in the systems, which I think is just amazing. But let's move on. So we've created our models with charge going over, displacement going over, creating rotating gears of positive and negative that would circle the core. We've defined them as polarity structure. We've defined what that polarity structure is, what the icons are, and that it's the same here as the yin and yang. And now we're going to look at it slightly differently. The torus layers, which form around these cores, well, we can just use this one, right? This is the H equals 8 pi squared Anapole structures that are compressed into this core and have displacement. That displaced core has velocity that's down on the page. And then each of these becomes positive and negatively charged, right? And these are, this is this structure here. So you see the core with the charge in and the velocity out, right? And it causes these rotating currents that you can see. And these rotating currents are now defined, coming down here. And the way that you need to look at them in the whole system is that they create a torus around the core. So these two combined to create a torus, and these two combined to create a different torus outwards, and there are multiple toruses. And this is just the way of looking at H is the Planck constant at the core, and H squared, right, is the core of this torus that's orbiting the central core. Okay? Thing is, once you realize that each two of these create their own torus, and that torus is going to have a core, and that torus orbiting this creates a place of accelerated space, then we've actually found Einstein's position in the fields. Think about what Einstein did real quick, and don't do the math. I'm not going to get lost in the math on this. I don't want you to. This is about models and theories, not about math. But listen to what scientists, right, even the greatest scientific minds in history, have said about Einstein. First, Einstein came about by defining the path of Mercury, which we now know as a magnetic monopole, accelerating as it moves inwards, which is against Newton's laws. So we understand what he's defining, why he came up with his equations. And now what we're going to do is to define where, again, fields are not everywhere in space. So if the speed of light exists, as he says it does, and I know that it does, I'm going to prove it mathematically later. Just stay with me. Then it can only exist in certain spots. But you haven't thought about this. It hasn't occurred to you that Newton's mechanics are they're not universal. The universal gravity is a myth. Gravity is caused by, it's a local effect created by the atmosphere of the inner planets or any charged dipole. And it gives mass, the atmosphere, to the particle because it's a force in, charge out system. That's it. So Newton's right. Now, when Einstein came along, he overwrote Newton. And now, I'm not saying he proved him wrong. I'm saying that all of Newton's equations exist inside Einstein's equations. And they exist there because they're true supposedly at low speeds and low mass. Well, that's not quite right. They're true, but only around charged dipoles and charged monopoles where force in, charge out exists. And that's only half of the things in existence. And it's not universal. The thing is when we understand that about Newton, then we have to extrapolate and say the same thing is true about Einstein. The things he's saying are true. He encompasses Newton, and he expands around Newton into a larger arena, but he is also not universal. So what is he explaining? What's he defining? Where are the parameters of where he exists and where he doesn't? And the thing is Newton, E equals mv squared, defines this orbital field of the core that we're talking about, okay? But Einstein, if you listen, go past the fact that he was just trying to define the motion of Mercury, and listen to what the scientists say about what he's really defining. Curved space and time. So let's take a moment here and define why Einstein calls his unknown parameter time. Well, at the time that Einstein lived, trains were the best public transportation around, and they existed between countries in Europe and all over the world. But, he was from Europe. That's where he was thinking, trying to make his fortune and get along. He worked in a patent office where people were constantly, because the big thing at the time was you were trying to get trains to leave and end up in certain cities at the same time. Everything was about time. In his mind, it was about time. Trains and time. So when he had a variable he couldn't quite define, the first thing that came up, and the one that made sense because nobody could argue with it, was let's call that variable time. It's not time. But for now, what was he trying to define? Time and space. But not just regular space, not just any space, not just flat or squared space like Euclid's. right? Curved space and time. Why curved? Right? Where do curves exist in nature exactly? And why would it be curved? Well, these toruses around the core, as I've defined them here, right? At any point that you can point to on this surface, it's not just curved in one direction. It is a complex curve in multiple directions. So where's Einstein's equations talking about? Well, these toruses. These toruses that then circle the core, right? There's 4 of them here because there are 8 of these rotating gears, if you want to call them that, right? And 2 of them combined create a torus around the core. That would look like this, and there are multiple toruses. I only put one here because I'm not an artist, believe me. So, if you listen to what scientists tell you, Einstein is defining curved space and time. So we'll deal with time in just 1 second. But curved space is a torus. So these toruses around the core in this field is what Einstein's defining, plain and simple. And these toruses have complex curves at every single point in space. And when they also have velocity, you'll notice that there's an arrow on this showing you that it has a direction, and the core of this is h squared. Now, why is that? Why is this core h and this is h squared? Well, the square around this means that you have a core to this torus, right? And layers outward, which you can see here, from that. And this is accelerated core. The core itself is moving around the core of the torus, is circling the core with velocity, the primary core of the field. Okay? So, what is Einstein's time? It's acceleration, period. Acceleration and deceleration. So when we talked about fields, like our star, accelerating and decelerating because of orbital resonance and the passing of energy inward and outward, what you really get is, in the end, you have to come to the conclusion that Einstein's time is relative acceleration and deceleration to the core. That's it. So if his time is relative acceleration and deceleration of particles compared to the core, then space-time curvature is this torus, where he's defining complex curves at any point in space around the core. And that's where Einstein exists. The accelerated core in these toruses, right, is limited, right? The speed of energy is limited to the speed of the particles, to that accelerated core traveling around the core, the primary core of the field. Why would that be? Well, I can show you mathematically, and I will in just a short while here, but imagine that light is a ship. Now, if you know anything about ships, you'll understand hull speed. Those giant ships with the sails, right, from hundreds of years ago, they could travel around the world, and they could do it fairly easily. And that doesn't make a lot of sense if you think about it, because this huge, massive weight and these giant ships are being pushed by just this little wind. And what we've learned is that the whole speed of a ship is defined by its length and its displacement. That's why they call them displacement vessels. And the thing is even a giant ship, if you're only going whole speed, can be pushed to whole speed with just the tiniest amount of energy. In other words, those giant wooden ships, if you put the engine from your car in it with an efficient propeller behind it, it can easily push it to whole speeds. That whole giant ship requires a very small amount of energy to reach, right, whole speed. The thing is, once you reach whole speed, if you want to go faster,
the energy required to push it becomes exponential. Meaning, if the whole speed is 10 knots, to go 11 knots, right? Let's say you could go 10 knots for 300 horsepower, because that's whole speed. If you want to go 11 knots, you're going to require 400 horsepower, right? A full 33% more to gain 1 knot. If you want to go 12 knots, it might be 600 horsepower, right? And if you want to go 13 knots, right, 30% more, then you're going to need 1,200 or 1,800 horsepower. And it just becomes an enormous amount of energy required to push it faster than whole speed. And light is very much the same way. Can something go faster than the speed of light? Sure. It's not a speed limit. It is a speed barrier. And that speed barrier occurs just like the whole speed of a ship. If you're going to try and go faster than the speed of light, you then begin having to push, just like the ship. The reason that the ship can go whole speed is because the ocean, the displacement, is carrying it along. On the other hand, if you try to go faster than whole speed, you then have to start pushing this giant wave in front of your vessel. And all that water in front of you then has to be pushed, which is why the exponential increase in energy is required. And when we're talking about the speed of light, we're talking about the same thing. You can go the speed 300,000 kilometers a second, because that's the speed of the core of this torus. And if you want to go faster than that, when you start pushing, you then have to push all the material in front of you as well. And that is just such an enormous amount of energy that, well, theoretically, you can't go faster than the speed of light, because then you have to start pushing the entire galaxy ahead of you, or at least a big chunk of it. And to go faster than the speed of light then requires exponential energy increases. And just to go to the speed of light would require so much energy that to us it's almost unfathomable. But to then go faster becomes theoretically impossible. You just can't do it. And this is why. This is Einstein's curved space and time are in these toruses around the core. But two of these de Broglie wave functions, right, create one torus. Okay? But you'll notice that the torus looks like these tiny little toruses, these de Broglie wave functions here, standing pilot waves, that are creating these larger toruses that Einstein's math is defining. And so when you get down here, two of Einstein's toruses create another much bigger torus, right? And those two, we had 8 tiny ones, and then we have 4 Einstein toruses. And then those 4 combine to create 2 large ones, and then those 2 large ones form to create one giant one around this same core. So it's layered toruses on toruses on toruses on toruses. And each one has a different core. Epsilon naught, mu naught for de Broglie standing pilot wave toruses. And the first ones here have an H bar core. So H core, H bar core, because the H bar is defining the same particles in a torus shape, a secondary core. And this defines the electromagnetic fields. So electromagnetism is formed in these first Einsteinian toruses created by the 8 de Broglie standing pilot toruses. And those are then made larger. 2 of those electromagnetic ones form to create, right? So you have electric and magnetic force created between these two. 2 of the electromagnetics form to create gravity and dark energy in these toruses. And time and space then combine those two to create one giant torus around the core. And this is how the forces that we understand form and exist, and this is how they are created. Newton is small, comparatively. Charge dipole, charge monopole. Einstein is the toruses around those that create the fields. And here's the thing. You got the Dirac particle antiparticle here. We're now showing both sides. So this is one giant torus, then 4 smaller toruses, right? Or 2 on each side. And those have the EM toruses inside. There are 4 on each side. And those have the tiny de Broglie standing pilot waves inside, which are the core that are creating these larger toruses around them. So I've said that they're Q4 particles, Q3, Q2, Q1 particles. What are these Qs that I'm talking about? How does this work? Well, this core and this system is a field. This is the field that forms around the core of the universe as we are traveling. The universe has motion, and that motion is deteriorated to create all of this structure. We call it the strong force, which is what this is. I'll get there in a second. Okay. How do I know that the mathematics agree with what I'm saying here? That I'm not just making this up? First of all, I wouldn't waste my time. But if you have a core and a particle is being ejected from that core under displacement, it would go above that first positively charged thing, and then it would rotate over in a helix and go under the next, and then over and under the next, outward in this helical pattern you see here. So this is the beginning, right here, where you're on the plane of density that separates the upper and lower quadrants, right? Now, this is the plane on which the Hamiltonian and the Lagrangian play out. So we're really talking about the Hamiltonian and the Lagrangian here. Now, this Q1 phase is where it leaves that plane and moves up and back behind slightly, right? So this first quadrant, Q quadrant, is a Q1 particle, and all Q1 particles are charged dipoles. When you pass this center point, coming up and over, right? When you pass the plane of polarity, you go from a dipole, which is in the front, to a monopole, which is behind. So real quick here, we'll flip back to what we're talking about. The plane of density. These are the transitional planes. The 6-dimensional vectors create, right, the 8 quadrants of space separated by the 3 transitional planes. This is the plane of density. Epsilon space is above it. Mu space is below it. Negative to the left, positive to the right. Monopole behind, dipole in the front. So here, when this leaves, it is above the plane of density, right? So we're talking about a particle in epsilon space. So Q1 particle is a dipole, positively charged particle. And we call it a dipole charge. When it reaches the plane of polarity, it switches from a dipole to a monopole. So then you have a positively charged monopole. And we call that a charged monopole. It's the star. As it continues down, it's still a monopole, but now it crosses this plane of density and is now below it. And below that plane of density, it switches. So it becomes a wave function, right? Because it's below this plane of density. So you have a wave function, magnetic monopole. When it reaches the very bottom, it again passes, right, this transitional plane of polarity and now moves back to the front again, but it's still below, so it's a wave function, negatively charged magnetic dipole. And it comes back up, and again, when it reaches this top plane, the plane of density, it's now in front, so it's a dipole, and it becomes positively charged dipole particle again. And these transitional planes tell you that the different places in a field, when defined as 6-dimensional vectors, which create 3 transitional planes, can tell you everything you need to know about a particle. So if you have 3-dimensional space, like we did in the beginning, right, and it's all the same, you know nothing. You can almost tell nothing. You can figure out where in these 3 dimensions it is, and you can track its acceleration or deceleration or its movement through the system. But that's all the space tells you. If, on the other hand, you use 6-dimensional vectors to create 8 quadrants of space, which define 3 transitional planes: plane of density, plane of charge, the plane of polarity, then when you transfer through this system outward, you go from a charge dipole, charge monopole, magnetic dipole, back to charge dipole, back to charge monopole. And it continues as it's forced outward. And that's it. So what does this tell us? Is this all just me running my mouth? Well, a little bit probably. But no. This is your Big Bang. Right? The core of the system is not a particle that's just tiny, that explodes. And I got to tell you, I really want to punch somebody. Let's define the Big Bang. First of all, is it big? Well, supposedly, according to your model, everything in the universe started the size of an atom. The size of an atom is not large. It's not big. So why would you call it the Big Bang? Second, you're saying this happens in space, where sound waves don't function. So it's not big, and there was no bang. Quite literally. It couldn't be. There's no sound in space. So, you get... And I am trying not to speak negatively of physicists and other people who have done work. I'm sure everybody's done some great stuff, but when you hear someone like Sean Carroll say, well, if you don't believe in the Big Bang, we won't even let you on the stage to talk because you're just a moron, you don't know what you're talking about. Well, I got to tell you, your Big Bang wasn't big, and it didn't bang, so it wasn't a Big Bang. Now, you can call it that. You can also call a field mouse a giant pink elephant. It doesn't make it a giant pink elephant. It wasn't big, it didn't bang, there was no Big Bang. Period. What you call the Big Bang and the expansion of the universe outward is what's happening right here. It's the helical path above and below these transitional planes that change things. Now, you may not want to believe that this is true, but why does a star go supernova? Because its velocity changes as acceleration and deceleration changes. It goes through a transitional plane and it transitions. So if a star does it when it goes supernova, right, then it happens on the largest scales. And if we know that, the charge of an electron becomes the charge of a proton when the Anapole structure of the electron inverts around a chemtron particle or dark matter. And again, I know your dark matter has gravity, and you're using it to fix your gravitational model, and I'm telling you that charge is what gravity is, which gives it mass, which means my dark matter doesn't have mass, which means it's not your dark matter. And I understand that. Don't yell at your computer screen and say, well, it can't be dark matter because dark matter has gravity but doesn't interact electromagnetically. Well, it's the charge dipole structure that allows it to interact electromagnetically, and it's that same dipole structure that gives it the force in, charge out, which is gravity, which causes its mass. So you can't have one without the other. It either interacts electromagnetically and can have mass, or it doesn't interact electromagnetically and it has no mass. And So I know that my dark matter, when I say dark matter, isn't your dark matter. But I'm stealing it anyway. I started, when I began all this, calling them chemtrons, which is another name I stole, and I don't remember where I found it. It was in a book somewhere. And I liked it, and I didn't know what to call dark matter that didn't interact gravitationally, and so I stole chemtron. The thing is, dark matter is out there, and it's a good name, and it fits, so I understand that my dark matter isn't your dark matter, but I'm still using it, and I don't care what you think about that. But dark matter is chemtron structure that has this inverted anapole structure around it as an atmosphere, and that's what gives it mass, right? And that's how these things form. So why is the Big Bang start with a particle that's just the smallest particle that can exist? Well, because it's one of these Q4 particles that I call, back here at the beginning, if you'll notice, we discussed it. Oops. In de Broglie's wave, this h equals 8 pi squared particles. This is Q4 particles. So one of those Q4 particles in this core, right, inverts. It's an anapole. It inverts. It becomes an inverted anapole structure around a quark, which is the smallest particle that we deal with, prove exists so far. I'm not going to get into any more with you right now. But this inverted anapole structure causes it to become a dipole charge. So a quark is a dipole charge. And this dipole charge is the smallest thing that it can be. It's got the charge of the Planck charge, right? So it's measured in the Planck constant, which is very, very small. And it expands, moving outward from a core, like this helical path that you see here. And this is actually the strong force. Why would I say that? Why would that be a thing? Well, let's be honest about this. The strong force is moving outward from the core, creating particles as it goes, as they transform from charged dipole to charged monopole to magnetic monopole to magnetic dipole and back. And they just go through this phasing as they move outward and they expand. So did it start as the smallest particle we can imagine, right? Something with a Planck charge? Yes, absolutely. Does it expand as it goes outward? You don't need inflationism. It just grows as it moves outward. So our universe started here as an inverted anapole, or as an anapole. It inverted around a chemtron particle to create, dark matter, which creates baryonic matter. And then it expands as it transitions again and again above and below these transitional planes outward. So why do we say that the strong force is a creative force and the weak force is a deteriorating force? Well, it's only because we don't understand that the strong force is actually deteriorating the velocity. It's deteriorating the velocity of the core of the universe. So everything that's made from this core, just like our star, the inner planets are accelerating it, the outer planets are deteriorating it, right? As we form baryonic matter and it moves outward through this system, are deteriorating the velocity of the core. We're slowing the core by creating these things. So is it a creative force? Absolutely. Is it a force that makes things and holds things together? Yes. Is it that because it's a positive force? No. It's a negative force. It's a deteriorating force on the velocity of the core. So the V naught of the core is reduced to create the strong force, which is this force here, moving outward. So each of the cores, okay, those toruses that we were talking about with Einstein, each of these also create particles. The thing is the creation of that particles reduces the velocity of Einstein's core, or the core of the toruses that Einstein's mathematics defined. And because we see that as deteriorating that core, right, we see it as a deteriorating force. So technically, both the strong force and the weak force are deteriorating the V naught of a core. But the strong force deteriorates the original core of the primary system, and the weak force deteriorates the core of the toruses defined by Einstein's mathematics. And that's the strong force and the weak force. And this is where they are in the system. Now, you may want to know what the electromagnetic force is and how it forms. And this is how it forms. You'll notice that if this is our star, this arrow, right, it creates this bubble around it of charge. And that charge is traveling through the galaxy, which is, as I've defined already, basically a cloud chamber or a magnetic field created by the core of the galaxy. And the core of that galaxy, right, then this, traveling in a helical path, creates layers of different epsilon and mu naught structure. Right? So this is a star creating the positively charged inside of a cloud chamber. The field that happens inside this, right, this electric dipole structure, it's only an electric dipole because it's a monopole with velocity through a negative field. The star is actually a charged monopole, but we call it an electric dipole because of where it is and how it's functioning. But this then creates this torus, right, of different layers of epsilon naught and mu naught that then define our solar system. And the toroidal dipole, right, which looks like this, is the galaxy in which we exist. The plane of the galaxy exists between these two, and you can see the cones above and below along the line of momentum. And this is accelerating and decelerating along that line of, the dimensional vector of momentum, really. And this is how the force looks that creates the galactic structure. In fact, if you cut this in half right here and look at only the top half, what you get is what looks like a hurricane. So a hurricane is half of a toroidal vortex or galaxy. And it should be easy to see. So the electric charge of the star, the electric dipole as they call it here, and the toroidal dipole of our galaxy combine to create an anapole structure. And the anapole is, of course, the universe. But it's also a Q4 particle. Again, Q4 is the helical Q1, Q2, Q3, Q4 phases as you're leaving this core that transition you through the transitional planes of density, polarity, and charge. Right? So you may want to know what causes force in and force out in the system. Truly define gravity. And this is it. If you have a particle, right? And these, you might notice these waves, or these look very much like these waves. See? De Broglie's standing pilot waves, right? That line up here. They look the same here, both above and below. And when you set these together like this in this anapole structure, what you get is above and below, right? Causing force in, charge out. And if you wrap that around a particle to make a sphere, then you get force in, charge out of a dipole charge with these trade winds, we call them here on Earth, but with these charges circling. And this is what and how our weather forms here on Earth. The reason we get these cold ice storms is because the toroidal vortex is at the top, pushed down against these other forms, bringing the cold weather. And these push back, and in most cases, keep the toroidal vortex at the poles so that that cold weather is kept up there. But this is how it forms. These are R8 structures above and below, right? And below, the force is up and charges down. And the one on top forces down and charges up. And when you put them together, they create helical force outward. That's the strong force. Okay? So when they come together in a sphere, you still have force in, charge out, an inverted anapole structure around a particle or chemtron structure, dark matter, that creates baryonic matter, giving it mass. And therefore, plain and simple, the strong force has been combined, has been shown to be the same thing as the gravitational force, just in a different structure. And, this is a charged dipole and how it forms. The charged monopole, I told you it's a star traveling through space. This is how it forms, charge in, or charge out, force in. And this will change the way you look at the way and what's happening inside the star. But I'm not going to get into that right now. That's for something else. And this forms, right? Gravity pushing in, dark energy pushing out of the galaxy that creates this plane, this toroidal vortex around our magnetic monopole galaxy. And again, time, and I haven't gotten there yet, though I will. Time is technically the deterioration of chemtron structure. So pi defines, oh geez, this is going to get, so pi is the relationship between the circumference and the radius, right? So if you were to break this down, you would say the size of this particle is equal to the time it takes for that particle to split. So this is T, right? And this is D. This is the displacement of the particle, and the particle splits in time based on the size or the displacement of the particle. And it creates an exact relationship. So if T2 becomes the square of time, then that becomes a line. So if you were to split this circle and pull the ends apart, you would end up getting a helical structure that looks like this. Again, I'm a horrible artist, but, right? And this is T2. This line lays down and becomes a line, and up above, then back under, and then back over, becomes a helical structure. So this circumference, this displacement, is split, and T2 becomes this helix. So pi, right, is actually true of a particle and a wave in this way. And all we're really showing here, the reason that I have to tell you this, is because time then it becomes the deterioration of structure, and it deteriorates based on the size. And it's this relativity that remains constant. And I'll explain that a little bit later as we get into this. And I know this has taken a long time. I'm sorry, but I am trying to define everything in the universe. So this strong force outward with time, or force being pushed in, right? Force out, time in, this helical strong force moving out is the Anapole structure we see here. This is Jupiter. This is our universe. And this is the core of, electrons. This is what an electron is. When you invert these anapoles, they become charged dipoles instead of magnetic or force dipoles, which we've been discussing. And all of it makes sense when you line these things up. So here's the problem. where are the other dimensions of string theory and M theory? If we've said that 6 of the dimensions are hidden in the 3 dimensions because, right, of the 6 dimensional vectors, if we give dimensions a vector, then it's not 3 dimensions, it's 6. So we've got 6, but string theory requires 10, M theory requires 11, and I'll tell you right now, the truth is there are 12 dimensional possibilities in our systems. And the 10 that string theory sees are right here. You'll see that they form, right? These also, you should have little arrows on these. This one's going this way, this one's going this way, this one's going this way, and this one's going this way. Okay? So this is the 10 dimensions, just like I say that magnetic monopoles can have, right? Their magnetic fields are circular, so they have no beginning or end. These dimensions have no beginning or end and are circular around these 6 dimensions. So this is the 10 dimensions in one formation. This is the 10 dimensions in a second dimension, or formation. So this is a particle, like charged dipole, magnetic monopole, right? This then creates a toroidal vortex, right? And this is what happens when you get to the Anapole structure. And this, right, going above and below, moving outward from the core, are all 4 of the additional dimensional vectors along the same plane that cause the strong force to move out from the core. And it's those 4 that, when snapped around a particle, become the charged dipole, like our planet, like a proton. And we'll get to why our universe is probably that same thing. Now in the book here, I switch gears. I explain galaxies or toroidal vortexes, how they're like hurricanes, what they look like, what the forces and how they exist are. I switched to gravity, which is why I originally started writing the book. Then I switched to dark energy. And then I switched to universes. And now the universe, electric dipole, merges with the toroidal dipole of the galaxy to create the Anapole universe. And that the Anapole universe then inverts. I want to say I'm going to hit it here as long as I'm on it, that the force out of the strong force of this Anapole structure that we're talking about inverts to become the gravitational force. So I have quite literally combined the strong force with gravity, which is one of the, and quantum gravity, of course, because it's on every scale that we're talking about here, which is what science has been trying to do for a long time. So I'm very proud of what I've done with that. And all of these things I'm, of course, very proud of. The thing is we get to the point of cellular structure, and I'm not going to get into that today. But I do show in the book how this strong force, when it's stronger than the core's displacement, can push in, creating a situation where it can split. And this is how cellular splitting occurs. This is how we duplicate cellular structure to grow into the complex life forms that we are. So cellular structures, also anapoles. This is how they split. This is why they split. And this brings me to one of the last things that I want to tell you when it comes to the universe. Just like our moon is a magnetic monopole, and the outer planets are magnetic dipoles, or force dipoles as I call them. You can use the word magnet, but on every scale it's force, and only in some scales is it magnetic. So I prefer force and charge to electric and magnetic, but you can call them whatever you want. The thing is when we start talking about things like covalent and ionic bonding in chemistry, and now that we know that pair production of our moon is happening with our planet and moving outwards, then we can say that there are similarities between all of these things that we understand in chemistry, with our actual solar system itself. And what that means in the end is quite literally that covalent bonds, as described in the literature, are the most stable, right? And if life is going to form, it probably forms in the most stable environment. And covalent bonds, which is the atmosphere, which creates the gravity, which is the reason for the mass of these particles, is the most stable. It's more stable than the moon. The moon is leaving us. Pair production has begun, right? So the atmosphere created by Mars's moon hitting us is more stable on the planet than the moon is, as the ionic bond that's circling us. And if we know that the universe is an anapole, and it is, then we have to ask, where would life probably form? Under what structure? If anapoles can invert to become charged dipoles, and they're the same thing, just inverted, the strong force, the force of the electron, inverted around the proton becomes the mass, the charge in mass of the proton. And the same thing can happen around any chemtron structure, which then gives it mass and gravity and a stable environment. When I wrote the book, came to the conclusion that our universe was an anapole. And it makes sense, like a Jupiter, creating this charged dipole structure, its moons, which have a charged dipole transferred to it from the magnetic or force dipole of the structure, the Anapole structure of the gas giant or Jupiter, or whatever you want to call it. So I was convinced for quite a long time that our universe was an anapole, and that's the way we would envision it. But when I realized that inverting the anapole is what causes electron holes to appear in metal hydride batteries, and what allows salt water to hold the mineral salts, same thing that allows moons to form around our planet and allows charged dipole moons in the outer solar system to have their own moons. Then I came to the conclusion that, like covalent bonding, we must live in the most, we live on the third planet. It's not too close to the sun. It's not too far away. It's the most stable position. And if that carries true, and I believe that it does, then what we're dealing with is quite literally, if we could zoom away from our universe and look back at it, it wouldn't be an anapole structure. It would be an inverted anapole structure around a chemtron particle. And it would look very much like a planet or a moon in the outer solar system in its most stable form, which is the covalent bond, which causes the gravity and the mass. And this is how it makes sense. So, do I still think that our universe is an anapole? Absolutely. But it's an inverted anapole on a chemtron structure. So what does that mean? Let's think about that for a second. It means when we get to the size of the universe and we zoom out, right, and we look back at our universe, what are we going to see? And it's going to be that little pale blue dot of Earth, which means our universe is Earth. It's not just Earth. It's the atmosphere of Earth created by the inverted anapole, which causes the gravity, which gives it mass, which is the stable environment in which life can form. And our senses, our eyes, our ears, our skin absorbing the heat, the warmth, all of these senses are our interpretation of this inverted anapole on a chemtron structure around a star, which means our universe will have a moon, another big particle out here, and it will look and be exactly like Earth. So you want to know what our universe really looks like? When you zoom out and look at it from the outside and in, get that photo from one of the Voyagers looking back that snapped a picture of our little blue dot, and that is your universe in every possible way. When people talk about saving our atmosphere, bringing down CO2, whatever you think, you're saving your universe, your everything. The mother of life itself is this atmosphere. It causes our gravity, it gives us our mass, and it is our protective shield. You are not leaving this planet. I know you want to, you talk about it, it's science fiction, but you're not going to leave it. This is Earth. This is home. This is our universe. It's our inverted Anapole structure. That's just my opinion. Take it, don't, that's your thing. I'm going to take another quick break before I come back and define for you how all of this forms and why. So I'm going to grab a cup of coffee. See you in just a sec. All right. Now we're going to talk about how all of these things form. In other words, if this was the Big Bang Theory, and obviously it's not, this is what happens before the Big Bang that causes orbital fields to form, which is how we get to the results of, what we've been talking about here. And I call this the theory of it. I call it the dark side of force because this is how chemtron structure, or dark matter, forms and breaks down to create the buoyant systems of displacement that cause baryonic matter to form and everything that we understand. The forces all come from this same structure. So the theory starts as this: dark matter, and I've written it out like this. I don't know if you can see that here. It's this, which is on the cover of the book. And 1n is Q4 particles at the core, right? And 0 is outside any known particles. So everything exists between 0 and 1 is both sides of the largest particle or chemtron structure that forms. And 2 is the beginning of baryonic matter around these cores. And 2n is the extrapolation of all those baryonic matter as it goes. So I know it's kind of hard to see here. Sorry, I'm not probably don't have the best equipment. I don't have anyone helping me here. So this equation defines how dark matter or chemtron structure. And again, I understand we're not talking about science's dark matter, because science's dark matter was created in order to maintain universal gravity in a system where it obviously isn't functioning, and they needed extra mass. And the problem with this is that dark matter has no mass, because mass is a function of the inverted Anapole structure, which causes gravity and mass. And without mass, there is no gravity, which means gravity is not a universal force. It's a local force. And so my dark matter is obviously different than, science's dark matter. I call it chemtron structure, and this is why. And what this basically shows, and I'm going to paraphrase the book here, is that, as you can see, this is all of chemtron structure here. And it's, imagine, if you will, a black hole, which is a centropic object. And I don't know if you figured this out yet by what we've been talking about, but since moons of the inner solar system are centropic and planets of the outer solar system are centropic, and moons of the outer solar system are also centropic, then there is a reversal of the second law of thermodynamics at the core of moons of the inner solar system, of planets of the outer solar system, and moons of the outer solar system. So there are more centropic, or what you would call black holes, at the core of all of those structures. And this is also about cellular structure. Those are, cellular structure is also centropic. And I'm going to stop here for a minute, because at the beginning of this, hopefully you followed along and you have gotten the sense that, at least in some ways, I know what I'm talking about, that I'm not just here, wasting your time. I certainly wouldn't waste mine. While it's true that syntropy, the opposite of entropy, is only a mechanical structure, right? It's a mechanical way of defining things, just like in your air conditioner. It's a mechanical expansion and compression that causes entropy and syntropy to, move energy in and out of the system. The thing is, and this is, again, it's like the strong force. You don't understand that the strong force is deteriorating the V naught of the core of the primary system, or you would see the strong force as a deteriorating force as well as the weak force. And the same thing is true of entropy. While I'm telling you that syntropy, just, so that you don't scream at your computer screen that I must be an idiot and you don't turn off the video and quit listening to me, I defined it simply as, syntropy is a mechanical system. That's what causes it. And that's the only way that it can be done. And that's true. I didn't lie to you. What you haven't grasped yet is that entropy is also part of a mechanical system. It's just that the system is our entire galaxy and our universe. And so you see it as just the way things are. But actually, entropy, and the second law of thermodynamics, is it's not a universal force. It's not a universal field. It's not the way things work everywhere, except in a couple small spots where syntropy, or the reversal of the second law of thermodynamics, happens mechanically. That's true. But entropy is also mechanical. So while I'm telling you that syntropy doesn't exist, that I'm not breaking the second law of thermodynamics, now I'm going back and saying, technically, entropy is also mechanical. So it's also not a thing except in the places where it does exist. So can you break the second law of thermodynamics? Yes. Is it broken, period? No. It's mechanical. But entropy is mechanical. They're both mechanical. So they're both right, they're both wrong, depending on the system you're in. And I'm not going to go into that any further, but it's all evolutionary too. So I want you to imagine black holes getting larger and larger and finally consuming everything that there is, right? Now there is a model for this in current, it may not be everyone may not agree with it, but there is a model in all of this that allows us to function. One second here, sorry about this. All right, sorry about that. I had to take a quick break and answer my daughter's call. Imagine that a black hole becomes dominant and devours everything in the universe, and that everything in existence then is in this black hole. Well, all of those particles in the black hole still have motion to each other, and eventually, and now I know Hawking radiation, all this, you don't believe that this, the way it comes about in the end, and maybe it's this way and maybe it's not, but for the mental theory, just assume that a black hole consumes everything in existence until there's just one giant black hole. And in time, right, all of those moving particles condense and stop moving and becomes a solid particle. So this happens through the condensing of the black hole. And once all of the particles in the black hole that make it up, and I'm not going to argue with you about the structure of black holes right now, this is just a mental experiment. It becomes everything in existence, and then it condenses so that in all of existence, right, there's one particle. And everything in existence is inside this one particle. And I need you to picture that just for a second. Because what would happen after that? first you'd think that would be the end of everything and everything would be done. And the truth is, it would. But eventually, that particle would crack. And this is what we're showing here, or what I'm showing here. And space would form between the two cracks. And the space between those particles would be different than the space outside. The space outside would be 0. This is on this equation, these are these zeros outside. Right? And these ones, plus and minus, would be each half of this particle that's split. And this is where the constant of pi comes in. When this particle splits, as I showed you here, right? Pi, the splitting of this particle, okay, happens on time. Right? And the amount of time it takes to split is dependent on the size of the particle. So if we extrapolate that just a hair, what we come up with, is the bigger the particle, the longer it takes to split, right? But then it won't split exactly even. Imagine that it splits kind of like this, right? So that 1/3 is over here, 2/3 is basically over here, and that means this one will split twice before this one even splits the first time. In fact, then this will split again, and this one 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 will split, and this one will split, before either of these actually split. So what you get is the deterioration of structure of this giant chemtron particle that formed from a black hole that consumed everything in existence, and then its deterioration, its splitting by the constant of pi, causes different size particles to form over time. Since it doesn't split exactly evenly, one splits before the other, which eventually, when you extrapolate that, causes dramatic different size particles over time. And it continues to break down. And so you can see where pi, dark matter, splitting over time, right, is pi, but that pi is also in a wave function where if you split the two ends and separate them, you get the 4 quadrants of space. Extrapolated from a core in a helical pattern moving outward under force. So time is the deterioration of structure, and the constant of pi as applied to time relative to the deterioration of structure is why we have different motions in different places. And I know that this is hard to grasp, but it's true. The reason that time moves faster in space is because as you move outward, the particles are getting bigger and the energy moves more easily between these dark matter or chemtron structures. And I don't expect you to just buy this, but for the purpose of this theory, just hear me out the rest of the way. See, time is the first thing in all of existence when these chemtron structure begins to deteriorate. And once you have more than one particle, right, it splits, then you actually have dimensions. You're creating dimensions over time as it deteriorates. So the chemtron structure deteriorates because of time to create dimensions. And this is an evolutionary process. If you define evolution as consuming a resource, and right, the side effects of that consumption become the resources in the next system, then the deterioration of structure through time creates dimensions. So chemtron structure through the constant of pi evolves into time. And time, deteriorating that structure, evolves into dimensions. which is basically all that this is saying. And just like here, the deterioration of that structure as it's separating creates space in between the particles that is different than the space outside. And so you actually, time evolves into dimensions, which evolves into space, which is what I'm explaining here. Now I want you to stop for a second and think about all these particles in space layering, right? Which we know naturally that particles layer based on size. And this is true because any of the large particles, right? When you put them together, there's space in between them. And the small particles fall between the big particles. So if you took, if you've ever, for instance, filled a 5-gallon bucket with sand and gravel and then shook it, right? You shake. What happens? Well, the small particles fall between the big particles, which make look like the large particles are rising in the system. What's really happening is the small ones are just getting underneath it, and they're using their structure to prop it up. And because of this, it layers buoyantly, creating a buoyant system. And the system is wholly based on displacement. So what we're looking here is that the deterioration of structure is time. Time evolves into dimensions. Dimensions evolve into space. And the random sized particles moving through dimensional space creates layering based on size, and that layering is buoyancy. So time evolves into dimensions, which evolves into space, which evolves into a buoyant system of displacement. Now, in the beginning of the book, and I'll go back and I'll show it to you, you can see, in order to say, when I start the book, I start with laws and thesis, and the very first part of my law and thesis is that every particle in every system follows the path of least resistance in the action of buoyancy. Buoyancy creates the only force. Everything we see as a force is actually particles following the path of least resistance, which is defined as TPLR, the path of least resistance. And the resistance of any given particle is made up of other particles, each following the path of least resistance, or TPLR2, in the action of buoyancy. And what that simply is stating is that at the beginning of all things is time evolving into dimensions, which evolves into space, which evolves into buoyant systems that are created by displacement. And when you stop and think about it, you may want to argue with me, that can't be the only force. This is not everything in existence is not a buoyant system, and it is when you actually get to the bottom of it. Think of Earth and the layers of, the core moving outward. It's a buoyant system with force in, charge out. Look at the star. The way they define the way that it works. It's force in, charge out. It's a buoyant system, a layered based on particle size and mass and relative charge. Look at the way that the galaxy forms. Look at the Anapole structure of the universe. The Q4 particle. It's all buoyant systems based on displacement. Period. So, when I say that chemtron structure, the deterioration of that structure is based on the constant of pi, which creates time, and that time evolves into dimensions, and dimensions evolves into space, and space, right, evolves into the layering of all of these particles in three-dimensional, or actually six-dimensional space is the way that I'm defining it. Then buoyancy and displacement is what causes fields. So I put this in what I think is a fairly eloquent statement in the very beginning. I call it the architecture of reality, and I'm going to read it here real quick just so you can see what I'm trying to say. Clarke said any sufficiently advanced technology is indistinguishable from magic. Sorcery is the knowledge of the workings of the machine behind the curtain. Geometry is the system of structure of a measurement. It seems impotent to know the laws of physics and not the reason for the laws. Time is structure, dark matter. The deterioration of structure creates dimensions. Dimensions create space. The layering of particles in space creates buoyancy. Buoyancy causes displacement. Displaced particles are accelerated. Accelerated particles create fields. And the structure of fields is the reason for the laws of physics, Rationus Physicae, which is physical reasoning. It's the name of the book, and I chose it because what I'm trying to define here in all of this is the physical reason everything occurs from before the Big Bang to now, to everything in existence. It was the belief by many of the first intellectuals that the Physicae could be defined by the square and the compass. Many great minds have debated the circle and the square. In this manuscript, I revealed that the sphere is created in the cube that was formed by the tetrahedron, which is the result of the octahedron that forms from the layering of spheres. Using only Platonic solids and spheres, it is possible to model everything in reality. By changing a few basic axioms of number theory, like 0 and infinity, we can represent that proof in the statement, the one I showed you before. And under that, I wrote quadrat demonstrandum. And what that simply means is a lot of mathematical proofs. At the end, they write QED, which is quadrat demonstrandum. And that simply means what is to be demonstrated, what was to be demonstrated. And I believe I have shown what I set out to be, to demonstrate in the beginning. And I have this little bit of a theatrical flair. So at the end of every chapter, at the end of everything that I do, I put a quote by someone that matters to me. So in this case, it's Confucius, and he who knows all the answers has not been asked all the questions. It's the quote at the end of Architecture of Reality. But this is very simply the way that it really is. And I'm absolutely confident that you can build every single system based on Platonic solids. The only problem is you have to add to it. There are the 5 Platonic solids that Plato had, but then you also have to add spheres, toruses, and helixes. So there are 8, and I know they're not Platonic solids, but with those 8 shapes, 5 of which were the original Platonic solids, you can literally model everything in existence. I can, whether you can or not, isn't on me here. And this is why the deterioration of structure through time creates dimensions, which then creates space, which then creates, the buoyant nature, the buoyant layering of particles, which is a linear field. And then as the small particles in between these larger particles gain displacement, then displacement causes the formation of fields. And fields, the structure of fields, which is what I've been defining here, is the reason for the laws of physics, all of them. And you can't argue with it once you see it. It all becomes self-evident. At least it should. And if it doesn't, you haven't been following. So, fields cause baryonic matter to form. And this is, if you want to think about it as a technical machine, how it forms, imagine that this core of all of these Q4 Anapole structures that are compressed together, these very small particles, gain this thing called displacement. They become denser than the larger particles around them. And until this, in the buoyant layering of systems, small particles have fallen through or around larger particles, which is simply a way of saying that the larger particles are displacing the smaller particles. The thing is that at a certain point, enough small particles get together and become dense enough that they then begin to displace the larger particles. And that's the moment that fields form. That's why you'll see the cores in these theories that I have are small particles, because it's the force created by the compression of these small particles that give the larger particles acceleration outwards. As they're pushed in, they are displaced and pushed back out. And it's that spring action that gives acceleration to these larger particles, which then cause fields to form around them. So if you want to think about how cores are creating acceleration, which is causing based on displacement, which is causing these larger particles to accelerate, which causes the fields to form around them, that's everything. That's everything before these cores form. This is how the deterioration of these structures become buoyant layering, which cause displacement, which then give acceleration to these particles. And accelerated particles create fields. All fields start with a core outward. I'm not just making this stuff up. It's it's physics, literally, from the beginning outward. And once you see it, it becomes self-evident, and you really can't argue with it. And again, I'm not putting forward a model like string theory or M theory or multiverse theory that can't be tested. I'm telling you, go use Ampere's law to measure, take my word, at least before you begin the experiment, that our moon is a magnetic monopole. It's a negatively charged particle. Measure that, take its path, define the solenoid, see the magnetic field, realize that Mercury is doing the same thing, and it's testable. I'm not just making this up. I have a theory of everything that is no longer a theory. It becomes self-evident. And another way to say it becomes self-evident is P equals NP. And P equals NP. It's quite a true statement. And I'm not gonna go into P equals NP into the details of it. You can look that up if you want. But what it boils down to is that P equals NP simply is, if I'm smart enough to come up with a theory that explains everything, even if you're not smart enough to come up with the theory yourself, you can look at my theory and say, wow, that's the truth. That makes sense. And that's what P equals NP. When you boil away all the fat, that's what it is. And I'm telling you, this is not a theory of everything. This is a ToE, but this is the truth of everything. And I know what that sounds like. One guy coming up with all of these truths while all of science is arguing about them. Why me? How did I do that? And I don't have an answer for that. And I really don't care. P equals NP is real, and you should be able to see it in all of this. So matter, baryonic matter as we understand it, is formed from the core of these systems outward. As these particles are accelerated, they create fields. They keep gaining in acceleration, which causes the fields to get larger, which causes them to accelerate. Momentum hides this flip of the switch of acceleration and deceleration that causes the helical path as it leaves the core. And this is how matter is formed. So you can see alpha particles in the core, 1 in h equals 8 pi squared. These are the cores, the ones we've been talking about. And they move outward, getting larger and larger. And so you get this omega particle. That's what I call the black hole that consumes everything and then condenses to create one particle only in existence. I call that the omega particle. And these cores that form, right, of all the smallest particles that gain displacement, I call those alpha cores. So you have omega particles and you have alpha particles. And alpha particles are black holes, really. And omega particles are giant chemtron structure, which form after alpha particles lose all their velocity. And they quit having momentum between them. And everything, from the quantiverse to the atomiverse to the universe to the megaverse to the infiniverse, each of these magnitudes exist between these particles. And when I say that the structure must deteriorate through time, and that time is based on a constant that we call pi, I understand that it sounds wrong, that it sounds like I must be losing my mind. But when you're done and you look back at all this, it's self-evident. There is no other possibility. So when I say that time itself is the deterioration of structure, then when the omega particle splits and deteriorates all the way down to the alpha particles, which then start sending baryonic matter back outward in the way that I just defined, what's really happening here is you can take the omega particle and the alpha particle, and on each side of the alpha particle will be another omega particle, and on each side of the omega particle will be another alpha particle. And so all of time exists between the deterioration and then the acceleration of particles, and it's symmetrical. Time itself is symmetrical as the omega particle deteriorates to alpha particles, which then become an omega particle, which then deteriorate to alpha particles. And so even time is not just a one-time thing. It resets and begins. And when it resets, the laws of physics and everything reset with it. When alpha particles become omega particles, that then deteriorate to alpha particles, which then becomes an omega particle, which then deteriorates to alpha particles. There is an infinity. But it's not an unknown infinity. It's a repetitive infinity. It's a symmetrical infinity. Time itself is symmetrical in this model. And to modern science, time must be asymmetrical. It must break, there must be a time symmetry must break, or it wouldn't be a one-way thing in modern physics. So this is a better model of the deterioration of structure, which then creates buoyancy, which then causes displacement. Displaced particles are accelerated, which is the beginning of baryonic matter. And when it's all done and said, they condense back into a black hole, which condenses and then splits again. And so time is symmetrical, and space is symmetrical, and dimensions are symmetrical, and the entire system is symmetrical. And there are no asymmetries, and they're not necessary. I'll leave that for now, and we'll move on. Mass, FV, FD, FC divided by pi squared. First of all, you don't need to divide the pi squared unless you're in one of the toruses that Einstein is talking about, which we are. So our local system would be divided by pi squared, but that's not a necessary part of mass. Now, I've defined mass as the inverted Anapole structure around a chemtron particle that then gives it a force we call gravity and defines its mass. Well, what this means is mass is variable, which I know goes against what you're thinking. So I'd like to just take a moment here, see if I can get it straight, to define what this equation is. FV, FD, FC. Well, FV is the velocity of a particle given to it by the next larger system. The star is being carried by the galaxy. The galaxy is being carried by, the universe. The planets that we live on Earth, right, are being carried by the solar system. The planet is carrying all the particles on it, like you and me. Our particles inside our body are being carried along by our system. So the FV is the total force of velocity given to any particle by the system that it's in. That's it. So FV is very easy to define, but it's a basis of mass. So if you take this FV and then you multiply it by FD. Well, what is FD? FD is the total force of displacement. It's your size. You are displacing. Now remember, I just said every system is based on buoyancy and therefore based on displacement. So you have the total velocity given to a particle by the systems that they're in. That's the FV. Then you have the FD, which is the total displacement, the total force of displacement given by its displacement, its size. right? So you have the total force of velocity given to you by the system. You have your size, the total force of displacement, and then that leaves Fc. So what is Fc? And Fc is then the relative acceleration and deceleration that separates you from the Fv. So you have the total force of displacement causes the total force of charge, and the total force of charge is the relative velocity to the system, the Fv. And that's it. That's mass. That's what gives you your charge based on your displacement relative to the system you're in. And it's that simple. And I know it doesn't sound simple to some of you, but to others, there should be a light popping off in your head. So let's keep going. This is how Fv is the velocity, which is what I just explained. The displacement, which is what I just explained. The relative charge, which is what I just explained. Charge is a pretty big one, and I'm trying to define it. So we go here to symmetry. Symmetry is the maximum minimum of any of these structures. Above and below dimensional vectors. And it's hard to explain. I've got it. I'll read what I wrote about it in the front, which is probably easier to grasp. Tridynamics is my version of thermodynamics. I don't believe that thermodynamics is a one-way system. It only is a one-way system in the galaxy, in the universe. So in order to finish thermodynamics and make it correct, you need to use tridynamics. And there's a small equation under here, and that is the vector of charge is always opposing the vector of force, and they are equal. Not equal, but always opposite. And that's all this really means. So it may look like an equation. It's not complicated. It's actually very simple. And everything that we've been talking about since de Broglie's wave is acceleration relative to the core. It's true. It causes, de Broglie's standing pilot waves, and it's true in, Dirac's equations. It's true everywhere. And that's it. So I try to define for you tridynamics, why it's different. And then I get into number theory. And I compare each thing. And there's a reason I use number theory, which is what I'm about to jump into now. But then that's the mechanics of the system, which is the layered tridynamic superpositions, and how de Broglie's wave leads to Maxwell's discovery, which he uses to define electromagnetism, and how it becomes the structure of everything. And then Einstein's continuum, the toruses around the cores, and the dimensions required to create them. Schrodinger's wave function, which is my orbital field, which is what I described as Dirac's equations, one, the other, neither, and both of the quad outputs to the binary system created by the unitary particle. Dirac's equation, again, which I define. Bohr's mechanics, and how Bohr and Rutherford even were correct, and that we have contaminated that, and we don't understand it. And if you look at your solar system and see that pair production is beginning through covalent and ionic bonding and the way that things actually function, then you come to quickly understand that Bohr was a lot righter than you say he was, and so was Rutherford. Our solar system does define atomic structure. Anyway, Darwin's evolution, I go into that a little bit, and how it affects the biology, and how biology is also just about displacement and the reversal of entropy and entropy. And then Pascal's triangle, the Mandelbrot set, which is going to come up here in a second. Shannon's logic, which I will, again, finish with number theory, which is going to be the end of this film. And then the analysis, the proof of what I'm saying. And in here is where I tell you that the moon is a magnetic monopole, and that you can simply apply Ampere's law to it. And when you do, you're going to find I'm right about the magnetic field created by the moon, which is a negatively charged particle, which proves it's a magnetic monopole, that Mercury is also one. And that all the rest of the things are, true as I stated them. Here's where it shows the comparison between the structures and how the structure of the Anapole creates a strong force. And when you wrap that around a particle, that strong force becomes the force of gravity, which connects, of course, quantum gravity and quantum mass, or mass in any, to the atmosphere, or the inverted Anapole structure, which also creates the ability for moons, or for salt water to hold minerals, or for metal hydride batteries to create electron holes that hold the energy in the battery. And then I touch on global warming and how you have missed the point of what's happening. And then unification. Probably shouldn't have added this to the book. I only added it because when I see the different religions, and yes, I touch on religion. When I see the different religions, I hear of, I see the Eastern religions based on their understanding of the universe, and it moves me. I hear it, and the yin and the yang equaling polarity and charge, but there's all of the Eastern religions seem to be a focus on the entire system, and then I see Adam, who focused on his family, and from the particle, from the family, from the core outward, which is opposite of the Eastern religions. And then I show that the path of the particle creates a third dimension, and that's science. And they're all actually talking about the same thing, and it's all physics once you realize it. And I probably shouldn't have added that, because I'm not trying to change anyone's religious beliefs. But then I hit conclusion, where I basically just tell you that I'm very proud of what I've done, and that all of these things can be, self-evident once you look at it. A little bit about me, and that's the end of the book. So mechanics is about basically how the rest of this book interacts with the great masters. And so I'm going to take a moment real quick and go back to the beginning and just tell you that even though I'm saying all these things that sound completely different than some of the physics you're used to, the truth is they're not. And what I mean by that is, Euclidean space is 3 dimensions. I'm saying 6, but it's just creating 8 quadrants of 3-dimensional space. So was he wrong? No. Did he understand all of it? No. He also, or at least Euclidean number theory, kind of put, and I think it actually happened later, so it wasn't Euclid. I think it was an Indian mathematician that actually added 0 to the center of numbers, so that between 1 and -1 there's a 0. And in my number theory, I simply take that out. You can't have 0. You can't have a nothing in between. People keep looking for proof of the Riemann hypothesis, and actually, and I try to explain it a little bit in the book, but actually the Riemann hypothesis is proof that 0 can't exist between 1 and -1. But I'm not going to go into all of that right now, because we're talking about the universe and the way to functionally create and how it forms. So as long as you take 0 out of -1 and 1 from between the two, and you move it to the outside, like we did when the deteriorating chemtron particle splits to create space, then you'll notice it's outside, right, this equation. And it's the only place 0 exists. So, when it comes to Euclid, it's not one three-dimensional space. It's six-dimensional vectors creating 8 quadrants of space. And you gain so much more knowledge with 8 quadrants of space because you gain the 3 transitional planes that Euclidean space doesn't give you. Yes, Euclid was right. Yes, he had some good ideas. If you apply, Euclidean space to the 8 quadrants of space, then they're accurate, right? But you need the 8 quadrants of space to create the 3 transitional planes. And that's required to truly fully understand physics. So, I disagree with him slightly, but everything he did was right. He just didn't go far enough. And that leaves us to Pythagoras and the Pythagorean theorem. And in truth, the Pythagorean theorem is, again, accurate. Not Pythagoras's, of course, but it's accurate. We know that. So what we're looking at here is just an evolution of the Pythagorean theorem, really. And what I mean by that is, where the Pythagorean theorem, a squared plus b squared equals c squared, applies one orthogonal connection. You then jump to the second level of the Pythagorean theorem, if you will, which isn't his, but neither was the first one, so we're just going to call it that anyway. But that's the inverse square law. And you have the square law, which is the square, which is a Pythagorean. But then you have another orthogonal dimension directly through that square, which gives you 2 orthogonal relationships. So the Pythagorean theorem, a squared plus b squared equals c squared, is a 1 orthogonal dimensional structure, equation, where the inverse square law becomes a 2, or a second generation Pythagorean theorem, if you will. And then the orbital field, which is Schrodinger's wave function, which Dirac's equation is defining, becomes the 3-dimensional. The orbital field, my orbital field, Schrodinger's wave function, is a 3-dimensional or 3 orthogonal connection Pythagorean theorem. So you can see that Pythagoras was right, but he didn't understand the second or the third generation of the Pythagorean theorem, which isn't his. The second one I think is, I don't know if it's Kepler or if it's Newton, to be honest. It's somewhere in there with the inverse square law, and I'm not sure who came up with it. But the orbital field, as defined by this book and this film by me, is a 3-dimensional, 3 orthogonal connections. So the Pythagorean theorem is correct. And Plato, I've already told you, I agree with him. It's Platonic solids. You just have to add a sphere, a torus, and a helix. And if you add those 3, then you can define everything in existence, which is what he was trying to do geometrically. And then after that is Archimedes. Now, I heard Neil deGrasse Tyson say that everybody who is in physics kind of has their guy, and that Neil's is Newton. Many people's are Newton. I understand. Mine is Archimedes. I'm a density displacement kind of guy. So since my theory is based on displacement and buoyancy, it's impossible for me to idolize really anyone except Archimedes. And I don't disagree with Archimedes. But again, I expand on it. His idea of pi is the circle and the line. You have to separate the circle to create a helix, which lays down that central line. And, when you square that, it becomes, a helix. It becomes particle wave duality through pi, literally. So I agree with Archimedes. I want to add some more to it to get where we got to go to fully understand physics. So I'm agreeing with the great masters. I'm just adding a little bit more to Euclid, to Pythagoras, to Plato, to Archimedes, And next of course, Copernicus, and I agree with Copernicus, obviously. He noticed something, but he was an observer. He didn't actually logically build, at least not the part that I read or understand. But I agree with him. So Copernicus, Galileo, again, I have nothing to add. They did their thing. They were right. High marks. Excellent. Then Kepler. And Kepler wrote the equation. And I'll pull this back over here real quick. Kepler wrote R3 T2. And this is an equation that makes perfect sense. And what it means basically is if you have something here and something orbiting it, right, the amount of time it takes to cross here, from here to here, creates a pie shaped, and the area of this pie, right, will be equal and opposite the pie over here for the T2 on this side, even if it's not right. Even if this is farther away, this T2R3 is a relative comparison between the time it takes to traverse here and the amount of area in here. And the same thing is true over here, even though it's, right? So if this is shorter, if this is closer, and I didn't draw this very well, but if this is closer, right, then this will be a larger, right, which means the particle has to be moving faster here, but the area inside this will be the same. And that's R3T2. And in the book, I show you that because it's an orthogonal connection, and I understand orthogonal connection symmetry, I think better than a lot of people before me, that T2, R3 is also correct. And you can invert Kepler's equation because R3 becomes the sphere of the particle, and T2, I'm going to do it down here, here's your core, here's your particle, T2 becomes the tether to this R3 structure, which is this sphere. So T2R3 is just as accurate as R3T2, but you can reverse it, and I do that in the book, and I show you why and how. So again, I agree with Kepler. I'm not saying he was wrong. I'm saying that if you take R3T2, you can reverse it because it's an orthogonal symmetrical relationship. That T2R3 is defining something else, but is also accurate. Anyway, that's Kepler. From beyond Kepler, we hit Gauss. And again, Gauss was right about charge monopoles. And he built models of magnetic monopoles. He just didn't build one he was happy with and couldn't find a way in his own mind to make a model that allowed him to see it. So Gauss was correct. Wrong about magnetic monopoles. I think I've proven that. If I haven't, I will when you apply Ampere's law, which is, again, Ampere. I agree with Ampere. I'm simply saying that magnetic monopoles exist. Our moon is one of them. And that if you apply Ampere's law to our moon, you'll find that Gauss was incorrect on his second equation. Out of the four, Maxwell equations, there's two by Gauss, one by Ampere, I think one by Faraday. And so I agree with Ampere, and I agree with Faraday. And out of the four equations, okay, Maxwell's equations, we get, I'll do this here real quick, you get Gauss, Ampere, and Faraday, and their equations. All right, I'm not going to write them out here, but all Maxwell really did was create an orthogonal connection, right? A symmetrical orthogonal 90-degree connection between these bottom two, which are defining waves. So in a way, you could say that this is Ampere's is a wave dipole, and Faraday's a wave dipole, and that Maxwell, all he really did was create an orthogonal connection between these two to define them, which is how we define electromagnetism. Okay? So what I'm saying is I agree with Maxwell and all of these people except for Gauss on this second equation, which is, divergence times B, or the magnetic field, equals 0. So that would look like this. Dot B equals 0. This is the third equation. I'm saying you have to mark that out and put a 1, which is to say that they can't exist. I've explained to you how they can exist. So I'm correcting Gauss here. But what I'm also doing is, like Maxwell, I'm creating an orthogonal connection between charged monopoles and magnetic monopoles. So while I disagree with Gauss on one thing, I'm also correcting the 4 Maxwell's equations to create an orthogonal connection between the two particles, Gauss's equations, just like Maxwell did to the 2 wave functions. So again, I'm not disagreeing with the great masters. I'm agreeing. I'm expanding it a little bit farther. And then we go from them to Tesla. The reason I bring up Tesla is because some of you are going to disagree with the one, the other, neither, or both output of Dirac's equations, where polarity and charge are opposing each other and symmetrical or orthogonal to each other. And you're going to say I may be wrong about those, right? Well, I think I understand polarity better than pretty much anyone who's come before me, or at least in the modern world. And my proof of this, people are going to say, well, what experimental evidence is there? Well, one of the most repetitive, created, and manufactured products in the history of the world is the alternating current rotational electric motor by Tesla. And the thing is if you go back and look at it, Tesla's, I'm going to pull this back here, Tesla's alternating current electric motor is, give me a second here, sorry, is what we're talking about here on Dirac's equations. What do I mean by that? Well, 0/3 is 1. 1/3, right, is 3 in a base 9 system. 2/3 is 6. And 3/3 is 9. Which gives us 1, 3, 6, and 9. Now the way Tesla had a thing for 1, 3, 6, and 9. And it came out in his alternating current electric motor in the way he designed it. And since I've defined these as polarity, no thirds and 3/3, and charge, 1/3 and 2/3, and in a base 9 system, that would be 1, 3, 6, and 9. Okay? So 1, 3, 6, and 9 as thirds of a base 9 system define Dirac's equation that Tesla used to create his alternating current electric motor. His orbital field, based on the quad outputs in thirds, that agrees with Dirac. So this is Dirac's outputs created in a base 9 system that's 1, 3, 6, and 9. Now, Tesla had this thing for 1, 3, 6, and 9. He said it's how the universe works, and if you understand it and apply it like I did to electric current, which he did, alternating current, you understand the functional mathematical proof. So if the alternating current electric motor is one of the most produced products in the history of the earth, then every time you turn one on, you flip it on, and it works, you are experimentally proving orbital fields as the quad outputs in thirds of polarity and charge is real. If you want experimental proof that this model is correct, it is probably the most experimentally proven theory in existence. except, and we'll get to this in 1 second, Shannon. So let's keep moving here real quick. I agree with Tesla. He only applied it to electrons, unfortunately. And then we get to what? Einstein. And Einstein's equations, right? And his theories are true, but they're only true in the toruses around the core, right? And I have to correct that the speed of light is not universal, but other than that, I agree with him. He defined mathematically the path of Mercury and why it's there, and all I've done is define it logically in a way that you can visually interpret. It's a magnetic monopole that has no gravity and therefore has no mass and is therefore moving inward in a system where all the other particles with mass are moving outward. This is why Newtonian mechanics don't apply to it. So I've given a self-evident model that defines why Einstein's equations are correct and what they're proving in a way that should be intuitive to grasp. So I'm not disagreeing with Einstein. Just like Newton, I'm saying gravitation is not a universal force. And what that means is, hold on 1 second. Sorry about that brief interruption. I had to get another cup of coffee and answer someone's questions. But, all right. So what I've been talking about here is how I'm agreeing with Einstein and how it's not a disagreement over all of his equations. Simply that there's a switch that comes from acceleration and deceleration. Right? So if a particle has a momentum in this direction, there is an internal vector field that is either aligned with it or aligned against it. And this causes acceleration and deceleration. And acceleration and deceleration is Einstein's variable time. I know he thought of it as time. It's not time, it's acceleration and deceleration. And what that means is M theory, who says requires an 11th dimension, right? And I say dimensions have vectors, according to me. But the 11th dimension in M theory is acceleration and deceleration relative to momentum. Now, why do I say there are 12 vector dimensions where M theory says there's only 11? Well, because acceleration and deceleration, if they're going to be considered dimensions, and I say dimensions have vectors, then there must be two of them and they must be opposite. And see, momentum hides this vector field within it. So technically, there are 12 dimensional vectors in any system. M's theory says 11, and the reason it says 11 is because this dimensional vector can't both be applied. This internal vector field cannot both be applied to a particle or a system at the same time. So at any given time, you will only see 11 dimensional vectors, but 12 exist. So there are 12 possible dimensional vectors, 10 of which exist no, I missed it. There. 10 dimensional vectors exist like this. 6 right, along these straight ones radiating from a core, and the other 4 in these different shapes depending on how they're formed. And 4 of those dimensional vectors are round with no beginning or end. 6 are radiating from a core. And the last 2, so that's 10. That's the 10 dimensions of string theory. And the last 2, which only one can be applied, is acceleration and deceleration relative to the system you're in, or relative to momentum, if you want to say that. So 11 dimensions for M theory, 1 being relative acceleration and deceleration. Both exist though, which means there are technically 12 dimensions total that can be applied to a particle or any system. Now, it may sound to you like I'm saying string theory and M theory must be wrong, but I'm saying Einstein, we're correcting his time as acceleration and deceleration, and we're simply putting a limit on where it is. It's in the toruses around the cores, right? So it's not a universal force like gravity. It's not a universal speed limit of light. It is a limitation to acceleration and deceleration relative to the system it's in. So again, I'm agreeing with Einstein. I'm just expanding it slightly. And the truth is, then, you get to the people that came after. Bohr. I'm agreeing with Bohr. In fact, I'm saying Rutherford is more right than you're saying, and that Bohr's pair production, our moon, the static charge that holds you to it is 1.67, which is a way of measuring the static charge of the moon. And Bohr says that pair production begins at 1.64. This is anecdotal proof that it's not gravity, it's charge. And that Bohr was right. So I'm agreeing with Bohr in most cases. Now, when we get to the deterministic part of things and his inability to fully grasp quantum mechanics, then I disagree with him, of course. But I'm agreeing with Bohr. I'm agreeing with Einstein. I don't agree with Heisenberg. I want to fucking slap him. I'm sorry, I shouldn't have said that F word, but he allows for uncertainty to be a law. Just to say you can't know something. And there is no better way to absolutely guarantee that you can't know something than to tell people that it's unknowable. What that basically says is, if I'm not smart enough to understand it, it can't be understood. And I just want to slap him for that. He didn't understand orbital fields. He didn't understand the way fields form. The Lagrangian, the Hamiltonian that plays out on this quadratic surface of density and the quad outputs of charge and polarity on this plane of density as defined by the Hamiltonian and the Lagrangian. When you understand the 8 quadrants of space as I've been defining, then the uncertainty of Heisenberg vanishes. Period. I'm not going to prove that to you here today. We're already 4 hours into this. But let's go past them. Let's hit Shannon here real quick. Why are there 8 bits in a byte? Well, it's an orbital field. You're accelerating and then decelerating a system just like Tesla does through his electronic motor, alternating current. And you are applying then the quadrants of space, the 8 quadrants, and each one can hold a bit. So why are there 8 bits in a byte in Shannon's byte? Well, because it's an orbital field, just like I've been defining. This is a byte. And each of these quadrants of space can hold a bit. And you're creating this byte in an electrical wave, right? By pushing and then pulling back. And you're creating this orbital field with 8 separate spaces for you to install information. How do I know this is true? Well, I'm going to do this a different way in a second, but for now, let's apply his orbital field. Okay. Shannon is correct in everything that he's done, except he's not. He didn't go far enough. He didn't explain it well enough. See, I'm agreeing with all these people. I gotta go a little farther with each one in order to get you to fully grasp. So let's switch to computer science here real quick and do some fun stuff. I said that a unitary system, one particle, has a binary output, right? And that a binary system, 2, has quad outputs, okay? And that a ternary system, 3, has 8 outputs. Now, the ternary system is the 3 transitional planes. So here is the 3 transitional planes that create 8 quadrants of space. So this is the 3 that creates 8. 2 that creates 4 is the particle in motion causing a difference in density above and below this line, the plane of density. And so you have a duality, right? A binary system with quad outputs. So the Dirac's equation that sits above this plane of density, as defined by the Hamiltonian and the Lagrangian, are the quad outputs to this binary system. And it's a single particle in motion that creates that binary system, right? So you have a single particle in motion creating a binary system. That binary system has quad outputs that create a ternary system of 3 transitional planes creating 8 outputs. So that is Shannon. How do I know this? How can I prove this to you very quickly? Well, in computer science, in all of computers, you're being lied to. They say that our computer is based on a binary system, but it's not. It's a unitary system. This is the way your NP connection works, right? You have this line going in and this line going out, and an orthogonal one here, which is a gate. And when you fire this, it closes and doesn't let it through. And when you don't fire, it allows it to pass. And so the output of this junction is 1 or 0. It either allows the electron to pass or it doesn't. It's 1 or 0. And that's your binary system. So now you're saying, well, wait a minute, you just said it was a unitary system. Well, it is. This is one line. Think about it, if you will, as a light, just to make it simple in your own mind. Right? One light can either be on, right? The light can be on, or the light can be off. No problem, right? So we have 1 or 0, but it's still one light that's either in one of 2 positions. So our computers work this way. And this is actually a unitary system. It's a single system that's either on or off. So once a unitary system has a binary output. So when they say our computers are binary, that's what they're talking about. So what does that mean? Well, you've heard of quantum computing, right? So what are they doing in quantum computing? Well, that's a binary system creating quad outputs. So think of it as 2 lights, okay? Well, what do you get when you go from 1 light to 2 lights, right? They can either both be on, right? Or they can both be off, or one can be on and one can be off, right? And it can be one of either. So what does that mean? So they've created the same binary, all on 1 and all off 0, but between them, one can be on and the other one can be off, and you don't know what those are, right? And this is qubits, actually, right? So what is the difference between quantum computing in reality and regular computing, unitary computing? Well, regular computing has 1 light. It's either on or off. That's a binary output. So a single unitary system has a binary output. Now, qubits, quantum computing, ooh, right? Well, it's actually just 2 of those systems. And they can either be both on or both off, so you still have your binary system. Or, and in between those, one can be on and one can be off. And this is where you get this whole quantum entanglement thing. Well, if one is on, then the other one must be off, and you don't know whether one is on or off until you test it, and woo, right? they're lost. Here's the problem. They can't control the quad outputs to the binary system. Okay? Why? Well, because all you have is one on and one off, and one must be opposite to the other. Okay? So this is how computers work. Unitary system with a binary output. Qubits. Right? Quantum computing is a binary system with quad outputs. Okay? So they say this is the future of computing, but they're wrong. Why are they wrong? Well, because you can't control this system with a binary input. Okay? You can only create the system, but you have no interaction with it. There's no way for you to control this system unless you go to a ternary system. Imagine this with 3 lights now. 1, 2, 3. Okay? Now you can use the functions of the orbital field that I've been talking about to control the system. This is how it works. All 3 can be on, right? Or all 3 can be off. And so you have your binary system. Okay? You following? Now, you can also have one light on, but you have one light in 3 positions. So you can have one light, or one light, right? And this is in between all on or all off. Well, then you can also have 2 on in 3 different positions. In between all on and all off. So if you're going to build a qubit system, you can't control it because you have no idea what's happening. And you can't force anything to happen, right? So why is this, what am I talking about here? If you have a ternary system, you can have all on or all off, still creating your binary system. But inside that binary system, you can have one light on in 3 positions or 2 lights on in 3 positions. And if you use this, if you use your intelligence, your logic, to create an orthogonal connection between the 3 of these, then you can have 1 on or 2 on relative to each other in between your all on and all off binary system. And this gives you an orthogonal connection here and here and here. And those 3 orthogonal connections are how you control the qubits. Only, as we've decided, shown you up here, right? A unitary system has a binary output. A binary system has quad output. This is quantum computing and where they're at right now. And a ternary system has 8 outputs. And those 8 outputs are 1, 2, 3, 4, 5, 6, 7, and 8. And if you build your model for your ternary computing in this way, then you have 3 controls. Well, what is that? Technically, in computer programming, these 3 are tetrahedrons. And they represent in physics the eigenstates of mass. You can control, right, your ternary system. So these are qubits, these are bits, and these are Qbytes. So when they get done fucking around with, there I went swore again. When they get done screwing around with their binary inputs, which give quad outputs that they can't control, you will have to switch to a ternary system, which gives you the binary system, and inherent to the ternary system, you can align these, and when you align them, you give levers which allow you to control the quad outputs to your binary system. And these are technically eigenstates. And these eigenstates are how you will control quantum computing. But it's not quantum computing with qubits, it's quantum computing with Qbytes. And this is all Shannon. So if you have, and this is in the book, or at least most of it is, but, you know, humans interface in base 1, and we calculate in base 10. because it's easiest for us and we're simple creatures. But like the orbital field is in base 9, based on thirds in quad outputs, then, right, this is 0 third and is 1. 3 would be the ternary hardware that I just defined here. So if you compute, now again, they say that we're computing in binary. We're not. We're computing in unitary systems. So if you, right, qubits are binary systems trying to compute in quadratic outputs. If you jump to ternary, you get 8 outputs, which allow you to create eigenstates, which allow you to control the qbytes. So 1, 0, 3, 0 thirds is our understanding. 3, so this is the interface for humans. This is the human interface. 3 is the hardware, right? And I know I scribble a lot, but it's not what it looks like that you should be paying attention to here. It's what I'm telling you and how it works. 6 then is the software interface. And this is going to come out as 6n plus or minus 1, which is what I'm about to explain to you next. And then 9, which is 3 thirds, is how you're going to communicate. One, 3, 6, and 9. Interface, hardware, software, communication, transfer. And the only way to reach Shannon's limits is if you communicate in base 9. And I'll show you how if you want. But this is a 1, 3, 6, and 9 orbital field function that defines how each of these things are going to go. And 6n plus or minus 1 is where we're going to finish this video, because 6n plus or minus 1 is the primary equation to find all prime numbers. And I'm going to show you the equation to find all prime numbers here now. And that this is actually, I've talked about NP, or P equals NP. This is NP complete. So when you understand the software is running on NP complete and your hardware is running on ternary and your interface is unitary and you're communicating, transferring the data in 9, you can reach Shannon's limits here. You can reach, well, basically omnipotence here in NP complete if you run a ternary system, which creates a binary all-in or all-out system with orthogonal connections between these, giving you the eigenstates that allow you to control the system. I know, they're telling you can't know this. They're telling you that you can't control qubits and that they're lost in it and it's some crazy thing that can't be understood. They're wrong. They're just looking at it incorrectly. And so now, for this, we're going to do one more thing. I'm going to close this book and move it over here. Move this to where you guys can see it. And now I'm going to show you why 6n plus or minus 1. Right? And I'll bring back, it's in the book. Nothing I'm telling you here. It's all in the book, but maybe hard to understand, so this is why I've been telling you to it. So switch over here to primes. Here we are. Primes exist as geometric structure in all systems. 6n plus or minus 1 reduced by 5p plus 2p plus 4p through p2 or 1n defines all primes. Now, they will tell you that there is no equation to find all primes, but they're wrong. No. Some of you may have heard about a couple of other equations written by some intelligent people, and that's 4n plus 1, right? And 4n plus 3. So what are those? Well, you'll learn, as has been proven already, that all prime numbers end in 1, 3, 7, or 9. And there's a reason for that. They're odd numbers. And primes can't be even, or they're divisible by 2, and they're not prime. So all prime numbers must end in 1, 3, 7, or 9. That's already known. What this does is give you some equations to help you get there. So 4n times 2 is 8 plus 1 is 9, right? 4n times 2 is 8 plus 3 is 11. So these are ways of finding primes or prime symmetrical numbers. The problem is as I've already shown with 4n times 2, when n equals 2, plus 1 is 9. Thing is, 9 is an even symmetrical number. It's not a prime symmetrical number, which means 4n plus 1 and 4n plus 3 are accurate and will give you primes, but they will give you more than the prime numbers. They will give you even symmetrical numbers that are odd, which sounds funny at first, but 9 is an evenly symmetrical number that is considered odd because it's 9. So when you use these two, right, you end up 4n plus 1 is 5, and 4n plus 3 is 7, right? So all I'm doing, right, is with my 6n plus or minus 1 is creating a 6n here plus 1 or minus 1. So 6n plus or minus 1 still gets you to 5 and 7, right? Makes sense. 4n plus 1, 4n plus 3, 5, and 7. Only they use two equations. I'm only using one. It's more efficient. And let's try it. 6n times 2 is 12, minus 1 is 11, plus 1 is 13. Both are prime, whereas this showed 9 and this showed 11. One is prime, one is not, right? So mine is more efficient because A, it's one equation instead of two, but every prime number will fall as a, 6n plus or minus 1, period. The problem is you get more than that, right? You end up with some things like 9 showed up here that isn't actually prime, but is still odd, okay? So we call this all prime and prime symmetrical numbers will come from this, right? And all other numbers that aren't this are even or even symmetrical. So technically this is the base equation, 6n plus 1 or minus 1. Every prime number will be on that list, and I'll prove it to you in just a quick second here. But you also have to do, right? You have to, in order to take some prime symmetrical numbers that aren't actually prime, you need to include 5p plus 2p plus 4p repeated. And this will remove all of the non-prime numbers, or what I call prime symmetrical numbers, from 6n plus or minus 1, leaving only primes. And this is a polynomial algorithm, okay? This technically is not. So, did I write a polynomial algorithm that can find all primes? Well, yes, but it has additional numbers in there that are prime symmetrical but not prime. And this is what removes those prime symmetrical numbers. So you have all the primes in this, but you have some that are just prime symmetrical. And what does prime symmetrical mean? Well, what that simply states is that there are numbers like p2, right? So 3 is a prime, right? But p squared, 3 times 3 is 9. So 9 is, as I've already said, even symmetrical, not prime symmetrical, right? So what this does is removes all the additional things like 9 from 6n plus or minus 1, which will hold all primes. Now, the reason that this is still a usable, I don't want to say polynomial, but the reason that this is still a usable algorithm, right, that can run in near polynomial time, if you can't write it that way, is because you limit this. Just like 3 times 3, 3 squared is 9. Once you reach the p squared, right, which is p2, right, you no longer have to run this secondary algorithm on the first algorithm. In other words, 3 is prime, but 3 times 5 is 15, right? You'd remove 15, even though it's on the list of odds. Plus 2p, which would be 6, so 21. You would remove 21. This would, if in threes, this would remove 15 and 21. Plus 4p, that's 12, plus 21 is 33. So this would remove 15, 21, 33, and then you would repeat this process just through these again and again until you reach one of two things. There are limits. One is p2, so in the case of 3, it's too small for this to apply. But on larger primes, it will apply. So p2 would be 9 if p was 3, right? Why would we stop there? Why would we stop this algorithm? Well, because anything larger like 27 or any of the others would be symmetrical to 9, not to 3. So you can stop at p2. So you run this algorithm, reduce it by this algorithm through p2, right? The prime number you're talking about squared, or 1n. What is 1n then? Well, if you go back in my theory, 1n is the smallest particles in it's the limit of infinity. Let's put it that way. If 1 is every particle broken down to its smallest, then n is the total number of particles in a system. So there's going to come a point where your mathematics run past the total number of, I'm a physicist, I'm into particles, and I'm into particle physics, so there is no infinity. There's a certain number of particles, and that's it, in each magnitude. And that means if you allow your computer to run this forever, it won't run in polynomial time. If you set the limit of p2, or, the other side of that 1n, then it won't run in polynomial time, but it'll run damn close. And it'll prove that you can find all prime numbers. And here's my proof, my visual proof. Okay? I gotta grab my phone here because I don't do math in my head very quick. So let's do this. Let's take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, let's just do some simple multiplication. We know that all prime numbers must end in 1, 3, 7, or 9 because they're odd. And that proves that, all of them have to have that as the final digit. So it doesn't matter what all the other digits are. The last digit must be a 1, a 3, a 7, or a 9 in any prime number. And we know that. So 1 times 1 is 1, times 1 is 1, times 1 is 1. And you'll find that this repeats. So these are all going to be 1s. 2 times 2 is 4, times 2 is 8, times 2 is 16. We're just going to write the 6 because we only care about the last number. 16 times 2 is 32, so we're going to write the last number. 32 is 64. And so you're going to find that any of these end in 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, and it just continues. So any number by 2 will always have one of these as its last digit. Let's do it with 3. 3 times 3 is 9, times 3 is 27, times 3 is, see, here we go, I'm bad at math. 27 times 3 equals 81. 81 times 3 equals 243. 243 times 3 equals 9. And again, so we go 9, 7, 1, 3, 9, 7, 1, 3. This will repeat forever. Okay? 4. 4 times 4 is 16. That's 6. Times 4 is 64. Let's do it again. 64 times 4 equals 256. Times 4 equals 1024. And you'll notice that these all end up in 6, 4, 6, 4, 6, 4 forever. The last number will always be 6 or 4. Let's do it with 5. 5 times 5 is 25. 125. 625. They're all 5s. Okay? 6 times 6 is 36. 36 times 6 equals 216. 216 times 6 equals 1296. And again, these are all going to be 6s. Right? 7. 7 times 7 equals 49. 49 times 7 equals 343. 343 times 7 equals 2401. 2401 times 7 equals 16807. 16807 times 7 equals 9 again. And again, 9, 3, 1, 7, 9, 3, 1, 7. This will repeat forever. 8. 8 times 8 equals 64. So that's 4 times 8 equals 512. 2. 512 times 8 equals 4096. 4096 times 8 equals 32768. 32768 times 8 equals 262,144. So we're back to 4, which will then go to 2, 6, 8, and this will repeat forever going this way. Let's do it again with 9. 9 times 9 equals 81. 81 times 9 equals 729. 729 times 9 equals 6561. So this will go 191919 forever. 10 will always end in 0. 10 times 10 is 100, times 10 is 1,000. So these will always be 0, 0, 0, 0, 0, 0. 11, let's do it. 11, oops. 11 times 11 equals 121. Times 11 equals 1,331. Times 11 equals 14,641. So you see these all end in 1. 12. 12 times 12 equals 144. Times 12 equals 1728. Times 12 equals 20,736. Times 12 equals 248,832. 2 times 12 equals 2,985,984. And this will then be 8, 6, 2, and this will go on forever again. So, why would I be doing all this? Why is this important? How does this function? Well, this is a matrix of numbers by multiplying them against themselves and basically squaring them and seeing what the resulting last digit would be. So, why is this important? Well, we've already defined up here that 6n plus or minus 1 will define all primes when deteriorated by this through p2 or 1n. This is true because the last number will always follow these patterns. So what are we going to do? We're going to take this duodecimal system, this duodecimal matrix, duodecimal for those of you who don't pay attention, or 12, so a system of 12, and we're going to fold it back on itself to extrapolate it in base 6. So what is base 6? Well, if you look at the surface of a clock, you get, it's base 12, right? So we're going to extrapolate in base 6, which is just 1 through 3, 4, 5, 6, and then 7 would be 1 again, right? So 1 and 7, 1 is all 1s, which means, remember, all primes end in 1, 3, 7, or 9. So all 1s would then match with all 7s, because 7 is 9, 3, 7, or 1. 8 would be these numbers, not prime. 9 would match with 3. 10 would match with 4, can't be prime. 11 would match with 5, right? End in 1. But 5 and 1, being 5 and 11, are even symmetrical. They're magnitudes. And they don't create primes. And 12 would then be with 6. None of these could possibly be prime. So when you take this duodecimal system and you fold it back on itself, 1, 7, 2, 8, 3, 9, 4, 10, 5, 11, 6 equals 12. Well, this means that there are 6 possible lines, and the only primes can be on 3 and 9, 1 and 7. Which tells us what? Well, that tells us that out of 6 possible pathways, primes will only fall on 1, 7, 3, and 9, which are exactly 1/3 of this system. 1, 2, 3, 4 can't be prime. 2 can be. So 2/3 of all numbers are even and even symmetrical, and 1/3 of all numbers are prime or prime symmetrical. Well, where have we seen this before? Remember my orbital field, right? No third, 1/3, 2/3, and 3/3, right? Which tells us numbers fit within 1/3 and 2/3 of this system. All prime and prime symmetricals are 1/3, okay? Because they fall on 2 out of 6 lines. And all even and even symmetrical are 2/3, or 4 out of 6. None of the numbers that fall on these lines, as you extrapolate them outward, could possibly be prime. So all primes must fall on 1, 3, 7, or 9, which are only 2 out of 6 possible in a base 6 system if you take a duodecimal matrix and fold it around on itself. So 1/3 and 2/3. Why is that important? I mean, it compares to what we just said, right? I've said that, according to me, what do we know? All primes must fall on 1/3 and prime symmetrical, and even symmetrical are 2/3 of everything in the system. Well, there's one thing I haven't discussed yet in number theory and how this all works, and this is the fine structure constant. So I'm going to show you what the fine structure constant is, how it functions, why it's a constant, and how I know it. And then I'm going to show you what the other constants. There is a microstructure constant and there is a macrostructure constant on either side of the fine structure constant. And I'm going to show you how to organically create these, or where you see them and why. So why is this important? Why is 1/3 and 2/3 in my orbital field in de Broglie's wave function? In the double slit experiment, it shows up there 1/3, 2/3, no third, 3/3. One, the other, neither, and both. Any binary system has quad outputs. Now, in case you think that this is just for physics or just for, okay, it's not. In any system, unitary system creates a binary output. Binary system creates a quad output. Ternary system creates 8 outputs, just as I've defined. You want to know how this functions in real life? I'm going to show you the fine structure constant, but, even the most modern problems that we're having, which is, let's talk about sexuality, binary system, male and female. There's quad outputs. So this whole woke political thing that's going on right now, you can't put me in a binary box, they say. Well, only if you don't understand binary boxes. A binary system, like two sexes, male and female, has quad outputs. One, the other, neither, and both. And that's it. There is no, you can't put me in a binary box. You want to bet? You can be put in a binary box. As long as you understand, geometry and, how systems build. How is that so? Well, male or female, one the other, neither or both, are the quad outputs to any binary system. So you either are born male with a penis, or, that's 1/3 by the way, or you're born with a vagina, female, that's 2/3. Then you have neither and both are the only other options. So you're male, female, or neither or both. Those are the only quad outputs to any binary system, including sexuality. So when it comes to both, if you weren't born with a penis and a vagina, you're not both. Now, just to be clear, the Pope, right before, what was his name? Borgia. Right before Borgia became Pope, the Pope before him got a letter from the King of Spain that said, I want a divorce. And the Pope said, we don't allow divorce in the Catholic Church. And the king wrote back, well, my wife has a penis and you don't allow homosexuality either. And that left the Pope in a conundrum. Well, it turns out that she had both. She was a hermaphrodite, I guess they call it, or whatever. And so he sent Borgia and another guy, another cardinal, to go and investigate. And when they went to found the Queen of Spain, they said, drop trow. And she had both a functional penis and a functional vagina. And so, whether you believe it or not, both does exist. And so, you are one the other, neither or both. If you weren't born with a functional penis and a functional vagina, you're not both. And if you are born with a functional penis, you're a male, you're one. If you're born with a functional vagina, you're the other. And if you weren't born with both, you're not both. Which means you are born one, the other, neither, or both. And those are the only 4 outputs to the binary system of sex in cellular entities. So you can't be put into a binary box? Well, yes you can, as long as you understand that binary boxes have quad outputs. And every single living organism can be put in one of those 4 boxes, whether you like it or not. So I'm not just talking about physics here. I'm not just talking about number theory here. It applies to every single system in existence, including sex. So, how does this function for the fine structure constant? Well, let's take a system with 1 unit, right? And then let's square it. 1 times 1 is just 1, right? Now, let's add 2 systems. Right now, we're just going to use the number 1 so that we can compare the system and not the numbers in the system. Well, what is a system of 2 1s? That's 11. So 11 times 11 equals 1, 2, 1. Let's look like a pattern here. 1, 11 times 11, 1, 2, 1. So let's go a 3-digit system. 1, 2, 3 times 1, 2, 3. And again, I'm going to use my calculator. Actually, I don't need to for this because it's, you understand the system. It's 1, 2, 3, 2, 1. You're starting to see a pattern here. So let's go to a 4-digit system. 4 1s times 4 1s is 1, 2, 3, 4, 3, 2, 1. 5. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5 is 1, 2, 3, 4, 5, 4, 3, 2, 1. Getting the pattern here? 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6 equals 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Okay? Let's keep going. 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6, 7 is 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. Let's do it with 8, and we're going to do this through 9. We can go through 12 right now. 7, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, 7, 8 is 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? And for this model, for this theory, we're going to stop there because there's no need to go any farther. So what does this tell us? Well, when you take a single digit system and multiply it by itself, square it, it's still just itself. When you take a two-digit system, and again, we're not focusing on the numbers right now, so every number is 1 to make it easy to see the patterns. So 11 times 11 is 121. Well, what is the highest prime factor, right, of this number? And the answer is 11, and it's the 11 squared. Okay? Well, what's the largest prime factor of 1, 2, 3, 2, 1? The answer is 37 squared. And this is going to be 101 squared, right? And 5 is going to be, I don't remember 5. Better do this real quick so I don't get it wrong. 1, 2, 3, 4, 5, 4, 3, 2, 1. Divided by, I'll just Google it real quick here. Largest prime factor of 1, 2, 3, 4, 5, 4, 3, 2, 1. And this is 271 squared, right? And 6 is 37 squared again. And 7 is, that's a good question. I don't remember some of these off. I can't remember 7 right off the top of my head. But 8 is, of course, 1, 3, 7 squared. And this is the fine structure constant. 9 is 3, 3, 3, 6, 6, 7 squared is the largest prime factor. And I'm going to try and find this one real quick. Largest, that's not good. Helps if I spell it right. .46, 49 squared, that's why I can't remember it. It's a unique number. It's the first real prime. I'm not going to get into that right now, but now, what does all of this prove? Well, it proves that 137 is a lot like 37 and 37 and 333,667, right? So I've said that 1 is neither. 3 is 1/3, 6 is 2/3, and 9 is 3/3. So what does that mean? Well, 136 plus 1 is the fine structure constant. And it stands for 1/3, No thirds, 1/3, 2/3, plus 1. And that means that 333,666 plus 1 is the macrostructure constant, and 3, 6 plus 1, both here and here, are the microstructure constant. So 3, 6 plus 1 is the microstructure constant, 136 plus 1 is the fine structure constant, and 333,666 plus 1 is the macrostructure constant. And why would I be saying that? Right? Well, because everything is linear in orbital fields that are neither one, the other, or both. One, the other, neither, and both. And this is how they come out in the structure of geometry in number theory as you extrapolate them. Why is that important? Well, it's important because let's have a little fun. Right? 3, 7 times 3, 7 equals, right? So the fine structure constant multiplied by 37 squared, which is the largest prime factor of this number, comes to 1, 3, 6, and 9. It's not a joke. 37 times 37 on 6 then would be 1, 3, 6, and 9. And the fine structure constant, 137 times 137, and this is where it is. It's 9 and 18 around 76, or 18, 7, 69. This isn't, right? It's hard to understand, which is why a lot of you got lost. But now let's take 333,667 times 333,667. Oh, well, this calculator doesn't show it, but it comes to 111,333,666,999. So 1, 3, 6, and 9 orbital fields on 3, 6, and 9, all 333,666 plus 1. 136 plus 1, 36 plus 1. What is the fine structure constant? I guarantee no one's ever told you that it's neither one, the other, plus 1 squared. Why is this important? What am I just making this up? Is this just another place that it pops up? Well, let's look at it. Honestly, mathematically. If this is an 8-digit system, and by the way, if I'm right, and I am, and Mercury isn't a planet, it's a moon, then you have the star, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We have 8 different positive and negatively charged primary particles in our system. Why is that important? How does it manifest itself in the other things we see so that this isn't just a coincidence? Well, let's take our 8-digit system right here, 137 squared, right? Which I'm telling you is 136 plus 1. And what we're going to do here is we're going to define in an 8-digit system, right? 1, 2, 3, 4, 5, 6, 7, 8. How can we possibly break this down evenly, symmetrically? Well, you can have 8 all ones. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8 divided by the fine structure constant, 137, equals 81103. Let's try that 8-digit system. And again, I said we're going to use ones just to make it simple, but now let's go 2. 1, 2, 3, 4, 5, 6, 7, 8 divided by 137 equals 162, 206. Thing is if you look at this and you put spaces, 22, 16, 6. So now you see the algorithm, what I call the algorithm of polarity. any 8-digit system, no matter what number you put in, if they're all the same, is divisible by 137 evenly. And it creates a polarity structure of 8, a magnitude of 11 by 3. Okay? And to me, this tells me the structure of our solar system. And here's why. You want to know how electromagnetism comes about. Well, you can take 8, 2, 3, 4, 5, 6, 7, 8, and you can break it in half, right? 4 here and 4 here. So let's try that numerically. And by the way, any 8-digit number with all the same digits is divisible by 137, period. So let's try it with two numbers of 4. Let's go any random 5, 9, 1, 5. Whoops. 5, 9, 1, 5. 5, 9, 1, 5 divided by 137. Look at that. It's a whole number. And it gives you another structure. Right? So let's try any other. 3, 5, 7, 3, 5, 7, 3 divided by 137. Whoops. That didn't do. No. 3, 5, 7, 3. 3, 5, 7, 3 divided by 137 equals 260,829. Why is that important? Because it lands on a whole number every time. So if you symmetrically break down any 8-digit system by the fine structure, it's divisible by the constant, the fine structure constant. And this is true of any of these. Okay, so like 3 can only be divided evenly in thirds. You can't break it down any farther. 6 can be broken down as 2 digits of 3 or 3 digits of 2. Okay, but 3 is already covered. So let's go 2. Right, 6 digits. So let's say 23, 23, 23 divided by 37 equals an even number. It will always, in any symmetrical system, it's always divisible by the constant. And this tells you what else. So 1, 2, 3, 4, 5, 6, 7, 8. Let's divide them into 2s. See if we can't break this system. Right? Let's try it. So let's try 7, 8, 7, 8, 7, 8, 7, 8. The digit 7, 8 repeated 4 times. Divide that by 137 equals, again, evenly divisible. And the numbers come out in a way that tell you something about the structure of the system. So any 8-digit system, like our solar system, divisible by all the same, so all 1s, all 2s, all 3s, all 4s, whatever digit, is divisible by 137. Any 4-digit number, whatever you choose, repeated twice, is divisible by 137. Try it. Any 2-digit number, repeated 4 times, creating an 8-digit system, is also divisible by 137. So this tells us that 8 can be divided 8 once, or 4 twice, or 2 4 times evenly. So this is an 8-digit system, right? And these are the forces. You may not understand it, but this is the equal and opposite 4 by 2 and 2 by 4 of electromagnetism. How do I know that? How is that? And how does this lay out? Well, 9. Let's go to the next one. 333,666 plus 1, or 333,667, is the macro structure constant I'm saying. Well, 9 can be divided, right? Any 9-digit number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try it. I don't know if I can on this calculator, but let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 333,667. Look at that. Why? Because the macro structure constant divides 9 evenly no matter what. Let's try it again. You can't do it 2 and 4 because it's 9, so it's the only other option is 2, 3, 4, 5, 6, 7, 8, 9. You divide by those three, and those three, and those three. So let's try it again. Let's go 7, 8, 7, 8, whoops, 7, 8, 7, 7, 8, 7, 7, 8, 7. Just divided by 3, 3, 3, 6, 6, 7 equals 2361. See how that works? Now, this is divisible by 33, 3, 6, 6 plus 1, right? And so is this. So if this is if this is charge and this is force, or electromagnetism, divided in our 8-digit system by the fine structure constant 136 plus 1, or what you call it 137, then the same thing is true of any of these numbers and their constant. And that 1, 3, 6, and 9 all share and 1/3, no third, or 1/3, 2/3, no thirds, and 3/3. And this is what these are, and this is how the systems can be broken down to create the forces. So let's just say that that's right. What would these three separated into thirds be? Well, this is a tetrahedron, this is a tetrahedron, this is a tetrahedron, and together these make the eigenstates of mass, which is a way of saying that our solar system is an 8-unit system, which is why we find everything divisible by 137, and that our galaxy is a 9-unit system, which is why it's divisible by this number evenly, 333,666 plus 1. And that all of the forces we see or understand, like electromagnetism, as defined by 4x2 and 2x4 in an 8-unit system, is the same as the eigenstates of mass, 333, out of a 9-digit system, divisible by the macrostructure constant. So we have 36 plus 1, the microstructure constant of 3 and 6, and we have 137, or 136 plus 1, the fine structure constant in our 8-unit system, which is our solar system. And then we have 9, which is our galaxy, divisible by 333,666. And when you multiply 333,667 by 333,667, or 333,666 plus 1, it is 111,333,666,999. And I couldn't make this stuff up. So why do I know that these are the eigenstates of mass and that they represent our galaxy? Well, this is the electromagnetism and represents our solar system. Well, let's have a little fun here. What was I going to show you? The eigenstates of mass here, and these here. Let's create the digital root of these. If you add 1, 3, and 7 together, you get, or in this case 136 plus 1, you get 9, 10 plus 1 is 11, right? And 11 times 11 is 121. And this is the speed of sound. Sounds funny, right? Why would the speed of sound be 121 in this numerical system? But let's watch something. Let's take 333, okay, and add it to 666, which creates 999 plus 1. And remember, these are all squared. Largest prime factor of all of these are squared. So let's square 999 plus 1, or 1,000. 1,000 squared is 1,000,000. So the speed of light, right, 1,000,000 times almost faster than the speed of sound. Well, if you take the largest prime factor of an 8-digit system, it's 11. 11 times 11 is 121. That represents the speed of sound. If you take 333,666 plus 1, you get 1,000. 1,000 squared is 1,000,000, and that's the speed of light represented in the solar, or the galaxy. We actually get to see the eigenstates of mass compared to electric and magnetic fields which are divisible in our unit system by the fine structure constant, and all of these things still apply. You can see the forces mathematically built out in number theory, because number theory is just built on a measurement of 1 multiplied by itself, geometrically building out in an orbital field of 1, 3, 6, and 9. There's just so much. I can't tell you everything that there is in one day. I have recorded this now for what appears to be 5 hours and 4 minutes nonstop. I had no notes. This is all coming directly out of my head, things that I know and have thought of over time. Every single thing that I've put in the book, the proof mathematically or through the geometry of number theory as you build out the measurement of 1 in any system, whatever it is, the constants, the microstructure constant, the fine structure constant, the macrostructure constant, the way that they combine to create the forces that we understand, and how they set the limits of speed for sound or molecules and the speed of light at 1 million, and the differentiation between the two. I was planning on basically leaving this this video at this point, but since I've taken all the time to do this, I'm going to that reflection's not really good here. I'll try and move it over here. I'm going to spend a few minutes, if you want to spend a little more time with me, which I understand if you don't, but explaining to you what the rest of the book means. And I'm going to read the first few pages to get you a Rationus Physicae. Simply means physical reasoning. I believe everything is deterministic. I don't just believe it, I know it. And that if you extrapolate in base 9, you lose all your infinities, which means 0.99 is equal to 1 because it's 3/3. And 0.66 is 2/3. And 0.33 is 1/3. So they don't run to infinity simply because they're complete at 0.3 or 0.33 or 0.66 or 0.99, and you don't need the infinities. So you can remove the infinities by working in base 9 instead of base 10, which you don't want to do because it's so easy for humans to work in base 10, but it's the wrong base for the galaxy. This equation I've already explained as 0 being outside everything, and that the deterioration of structure in my theory of everything here as defined by this is simple equation, I guess. It's not really an equation, but it's an algorithm that shows you how things function, how the deterioration of structure down to 1n then builds back out as baryonic matter in these 2s through 2n, which is simply the largest baryonic matter, and systems that can form from the smallest particles as they grow back outward between the 1s, which are, right, the omega particle splitting, and that 0 only exists outside that. I've already explained for you that this is a charge dipole, charge monopole, magnetic monopole, magnetic dipole, or what I call force monopole and force dipole. And I put those on here because they're very important to the understanding of physics in the book. I overlaid this with model theory mechanics analysis, and that's because these are the 4 chapters or the 4 main sections of the book that I wrote here. I put the yin and yang symbol behind these, and I did that simply. You can't really see the cover very well. Because it so exactly matches the polarity structure. I put a psi symbol on top of it, and I put a plus and a minus at the bottom of the psi. If the force in, charge out black particle in the white here represents our solar system and the charge, then these 3 planets along the top of the psi, right? You have Venus closest to the sun, Earth, and then Mars as you move out. I made the center post of the psi at the top into an ankh, which in Egyptian lore was the cradle of life, right? And so I put the cradle of life around Earth, the third planet, or the second planet, in between the three interior planets, right next to the positive charge, because we live in positively charged space created by our sun. That puts the energy in the core, the centropic system, at the center of our galaxy and our universe, and that means that this black area is negative space, which is why there's a negative, even if you can't see it, at the bottom of the psi. And then Neptune, Uranus, Saturn, and Jupiter going toward the positive side. And so all of that fits basically within the logo. That's what the logo is, just so you understand it when you look at it. Quaderat demonstrandum simply means what was to be demonstrated. I believe I've shown what I tried to originally set out to demonstrate. I'm sorry if you don't understand it, but it's not a theory of everything. This is the truth of everything, and it's very simple. These letters at the bottom is supposedly what was over Plato's university above the door. It means let no one ignorant of geometry enter here, since I believe everything is geometric in nature, and I can build everything in the system with Platonic solids, plus, as I've pointed out, spheres, toruses, and helixes. Then, to me, it makes sense. On the end here, I don't know if you can see, I've added what I call the algorithm of polarity, which I showed you just at the end of this video. I put a yin and a yang, and again I've repeated this symbol, which is the same as this symbol, because it's my theory of how everything forms. Again, at the top back here, the letters that say, let no one ignorant of geometry enter here. And then I'll read the back of the book here for you very quickly. There are thousands of books about physics and the nature of the universe. Most were written by popular scientists that hold degrees from Ivy League schools. These authors all studied with the same professors who all agree on the same structure. At the end of all those books, you get the same thing. We do not know. This book is a decisive answer to all those questions. This is not only a theory of everything, it is also the reason for the knowledge, not just the knowledge itself. I share an intuitive understanding of physics. The answers you seek concerning the physical reality are written out in plain text using common words that anyone can understand. While I do add a few basic equations, they are of the type and structure you would find in grade school. Some of the concepts may be complex, however, the structure of the reason and knowledge is communicated using logic for efficient understanding of the model, the theory, the mechanics, and the analysis. If you are willing to take a chance and read this manuscript, then at the end you will find, we do now know. And like always, I ended up with a quote from someone. In this case, it's a quote from Rene Descartes. If you would be a real seeker of truth, it is necessary that at least once in your life you doubt, as far as possible, all things. And I believe that. Opening the book, I'm just going to flip through the first 3 pages. Got the same cover thing, but black and white here without the planets on it. I dedicated this book to Eldon Wood, the teacher who sparked an imagination, my first teacher. He actually wasn't even my teacher. He was the grades ahead of me, but he sparked my imagination. And to Lawrence Finelli, a friend of mine who convinced me to write all this down. I'm going to skip ahead. This prologue is just a little thing to get me in the position of showing you that I'm about to create a solution, and that if you can't understand it, the only way to prove it is P equals NP. It becomes self-evident. And then I've put a small little area of P equals NP, and in order to prove P equals NP, I solved the traveling salesman problem in an algorithmic polynomial fashion. It's very short, very simple, but there's a very good reason it wouldn't work if it wasn't. The architecture of reality I've already read for you. And now I'm just going to simply read the law thesis in the beginning of the book, which I believe I've covered in all of this. I've read the beginning. Every particle in every system follows the path of least resistance and the action of buoyancy. Buoyancy creates the only force. Everything we see as a force is actually particles following the path of least resistance, or TPLR. The resistance of any given particle is made up of other particles, each following the path of least resistance, TPLR2, and the action known as buoyancy. Field theory is the knowledge of the structure of fields. Fields are either linear or orbital. Linear fields define three-dimensional E space. Orbital fields define six-dimensional M space, creating quadrants that define symmetrical transitional planes. The Young theory statement, which is what's on the front of the book and I've already explained several times, shows how linear fields form naturally into simplex from the layering of deteriorating chemtron particles. These simplex form back-to-back into magnitudes. Linear fields are the final stage of a chaotic system. The Young model is the representation of orbital fields. Orbital fields occur when a particle gains velocity. Orbital fields are the same at all magnitudes and create the structure that caused three buoyant systems to form along the axis of a field. The size of the orbital field is proportional to the displacement times the velocity, E equals mv squared. Young mechanics leverages M space to define 1 pi squared Q1, 2 pi squared Q2, 4 pi squared Q3, and 8 pi squared Q4 helical quadrants as layering. The dipole charge of gravity 1 pi squared by 8r3 is equal and opposite to the dipole force of the strong interaction 8 pi squared by 1r8. The charge monopole star 2 pi squared by 4r3 is equal and opposite to the 4 pi squared by 2r8 of the force monopole of the galaxy. The combined electric monopole and magnetic monopole form the dipole weak interaction. All forces form as the deterioration of the V0 of a core. The universe is a force dipole and has a cellular structure that forms from the core of the system outwards in the action of buoyancy, not from the past to the present. There was no Big Bang. 8 pi squared Q4 force dipoles are modeled as anapoles. Galaxies are force monopole structures with condensed energetic cores and a recirculating dark energy proton field. 4 pi squared Q3 force monopoles are modeled as toroidal vortex. Gravity is relative acceleration in an R3 particle. Gravity represents the inverted strong force decelerated to an object as an R8 wave in the form of an atmosphere. Gravity exists between the R3 surface and the inward directed monopole force created by the structure of galaxies, which I've already said is an inverted anapole structure. Dark energy is the outward directed force created by the structure of galaxies. Two of these forces create a toroidal vortex. Two toroidal vortexes create an anapole. Dark matter is a chemtron particle. The omega particle is the final chemtron particle. The deterioration of that particle sets the cadence of time and the dimensions of space. Dark matter is structure without the dipole charge of an atmosphere and therefore cannot interact electromagnetically. Dimensions are created by the deterioration of the particle of dark matter consuming the resource of time. Space is formed between the particles of deteriorating time consuming the resource of dimensions. Buoyancy is the natural action of particles in motion to align themselves based on size. The force of buoyancy is displacement. Orbital fields are naturally occurring structures formed from accelerated cores that cause displacement that creates structure that houses three buoyant systems all orthogonal to each other. Orbital fields are transformers. Baryonic matter is the naturally occurring result of orbital fields evolving to consume the resource created by orbital fields, which is structure. Baryonic matter forms when dark matter gains the dipole charge atmosphere. Mass is the cumulative force of baryonic matter structure of the three buoyant systems created by orbital fields aligned to each axis. FV, FD, FC, pi squared. Velocity relative to the core defines the four phases of baryonic matter: solid, liquid, gas, and plasma. The pressure ahead of and behind a core is separated by a transitional plane of density, representing a reversal in the second law of thermodynamics. Mu naught is the measure of relative density ahead of and behind the core along the velocity axis. Particle wave duality transitions occur at this plane of density. Charge of small particles we call energy. Charge always opposes force. The flow of charge is called currents. The vector of a current along an orbital path around a core relative to other flowing currents is the definition of positive and negative. Permittivity of space is the resistance to charge and can be measured as epsilon. Polarity defines the buoyancy in a system. Poles are equal and opposite each other under Platonic symmetry. Poles stack to form dipoles. The algorithm of polarity, or AOP, is R8 1.1 R3, where 8 is a dipole, R2 by 2 by 2, or R8 cube, and 3 is a monopole, R1 by 1 by 1, or R3 sphere. Displacement is measured as volume in Euclidean space and is represented in a sphere as R3. When displacement is measured as a force, opposite entropy, it represents a dimensional axis on the plane of V2 relative to the core and is best represented in equations as T2 for time. T2 represents the axis of pi in a wave in the same way that R and D do in a particle, and that's radius and diameter. Symmetry is the maximum and minimum of any of these forces on either side of all three axes at any scale. Magnitudes are best defined as base 1 and base 10 combined to form base 11, written as 1, 1, or 11, or 1.1 in the algorithm of polarity, where 8 plus 3 equals 11 defines the axis of charge and polarity, and 1.1 represents the axis of velocity or magnitude, and 137, 1 plus 3 plus 7 equals 11, represents the axis of force or displacement. The fine structure constant 137 is the measure in our system. It defines a unit that can equally divide all possible structure in our system of 8-digit opposing polarity structure. Multiple systems of 8 stack as 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. 137 squared is the largest prime factor of this number. Any single numeral 8-digit number is divisible by 137. The result demonstrates the AOP. Any 4-digit number repeated twice is divisible by 137. Any 2-digit number repeated 4 times is divisible by 137. Light is the frequency of waves created by a collapse of a star structure. The speed of light is variable to the density of the medium. Variations in the speed of light mean variations in the distances measured by light. Your measure of space is flawed. The speed of light, 3 times 10 to the 8th, and the E equals mc squared torus is the physical limitation of charge and is the reciprocal of the AOP, 8 times 3, or 8 times 11 times 3, where 11 is the magnitude of the limiting structure of the E equals mv orbital field. Magnetic monopoles exist all around us. The divergent times B equals 1, or equals I times R3 times negative C2 divided by mu naught is the equation for magnetic monopoles in our system. Earth-Moon is a centropic force magnetic monopole. 1/4 of all structure exists as force monopoles. Entropy and centropy define the direction of charge and flow. When E equals mc squared is centropic, it forms a sphere R3 times negative C2. When E equals mc squared is entropic, it forms a torus h bar squared by c squared around the core, symmetrical to the plane of V2 where the speed of charge is constant. Platonic symmetry can be expressed as 8 equal and opposite shapes: the sphere and the torus, the tetrahedron and the icosahedron, the cube and the dodecahedron, the octahedron and the helix. The first 4 share the trait of an exostructure and the latter 4 an endostructure. Primes exist as base geometric structure in all systems. 6n plus or minus 1 reduced by 5p plus 2p plus 4p through p2 or 1n defines all primes. Evolution is the formation of an entity to consume a resource. The side effects of that consumption are the resources in the next system. Survival of the system with the most resources is the first law of evolution. Survival of the fittest is the second law of evolution. Life has the same algorithm as evolution: mimicry followed by trial and error. Intelligence has the same algorithm as life: mimicry followed by trial and error. Information is the trail path of a particle orbital field traveling through a system, buoyant simplex. Omnipotence is the knowledge of all logic, not the knowledge of all information. Consciousness is the buoyancy that exists between the two halves of your brain. It exists as a capacitive charge between each animal's internal magnetic dipole and is the culmination of the 3 buoyant systems that apply force in the human psyche: omnipotence, creativity, and immortality. And then I close the thesis with a quote from Albert Einstein. If you cannot define a thing simply, you simply cannot define a thing. And I believe that I have defined these things for you and for everyone better than anyone who has ever come before me. It has been my honor to open your eyes. I hope that some of you, at least, have grasped everything I'm trying to tell you. If you have, congratulations. And I have to say, ages come and go. We had the Stone Age, the Iron Age. We have entered the technology age, the age of information. And if you've grasped what I'm telling you, then we have reached the age of reason. It's done. Good luck, people. I hope someone out there can hear me. Because once you see this, you can't unsee it. Welcome.